Regarder là-bas, tu peux.
Ce sera mieux. which is 30 years old.
C'est un beau costume? Tout va très bien.
Hi everyone, welcome to the central room here at AI Pulse 2024. My name is Paul Keon. I'm product marketing manager at Scaleway. I'm thrilled to be your host today in this room, well, a full room for this first talk. We have an exciting lineup. We have a lot of speakers, thought leaders. This afternoon, we are going to talk about investment in AI. We are going to talk about AI in healthcare, about generative AI, and many more topics. Whether you are joining her here in person or online, thank you very much. We are very glad to have you with us here. So, to kick things off, we are going to delve into an amazing first topic, the data pipeline from creation to training. This is mainly where the magic of AI starts. So, let's give a warm welcome to our first speakers, Jessica April, Senior Director Data and AI Partnership at Shutterstock. Welcome, Jessica. Ludovic Blusseau, Regional VP Sales Engineering Southern Europe at DataIQ. Dan Chester, EMEA Sales Director, Enterprise AI and AI CSP at Vast Data. And the session will be animated by Paul Mochkovitch, co-founder at Molia.
Thank you very much, Paul. Can you hear me? It's okay, the sound? Perfect. Thank you. So today, welcome to the AI Pulse talk on data pipeline from creation to training. We are excited to have three industry leaders today talking about the full life cycle of data. So from data preparation, licensing to transformation and to high performance storage. So I'm very happy to be here with you. Our panelists will discuss technical challenges and innovation at each stage, offering valuable insight into optimizing AI pipeline for success, I hope. So let me introduce each speaker. So Jessica April is Senior Director of Global Business Development at Shutterstock, leading a team focused on forging new collaboration in data licensing, particularly catering to machine learning and generative AI partnerships. We have Ludovic Blusseau, serves as a Sales Engineering Director at DataIQ, with over 15 years of expertise in data science, data management, and business intelligence. He brings deep knowledge of AI data pipelines and advanced transformation techniques. And we have Dan Chester, the EMEA Sales Director for Enterprise AI and AI CSP at Vast Data, bringing over 20 years of experience in data storage. He specializes in scaling AI data infrastructure and delivering high-performance storage solution for AI workloads. I'm Paul Mochkovitch. I'm co-founder of Molia. Molia is a consultancy firm. We provide best AI and data not students, but professionals to companies. And I'm co-founder of GenAI Network, GAIN, which is a French community of top GenAI experts. So I'm very happy to be here. So shall we start? Yeah, it's better to not in front of everyone make crazy things. So let's start with the beginning of the full life cycle about content and content creation. So my first question is for Jessica. Given your experience at Shutterstock, how has the demand for AI-ready dataset evolved in recent years? And what unique challenges does this present for content licensing and distribution?
Shutterstock's been lucky to be in the content business for a long time, and so for about 20 years, Shutterstock's been collecting data, if you can think of it that way. We see it as content from our contributors, but Shutterstock was founded on the concept of creating a commercially free, royalty-free marketplace. So this data set that's been curated over time, it's been been human reviewed over time, it's full of metadata, is now available as a data set. And so I would say it started a couple years ago. We started licensing data for computer science and computer vision projects, a little bit more on the smaller scale. And in the last 2 years, the need for data has exploded, where people are looking to kind of obtain the corpus of data that we have available, which represents almost 700 million data points and 800 billion metadata points. And so we're seeing a huge drive in scale across our library. And then, of course, with that scale, people are really specifically interested in specific quality indicators, specific metadata points. And so now I think that since foundational models have been developed, the scale play is still there, but now that fine-tuning's coming in, we're looking to kind of make different, siloed data sets that are ready for AI training for our partners.
It's quite a lot, in terms of figures. It's quite impressive. Still a question for you and maybe Ludovic. How do you balance the needs for diverse, high-quality data sets with the challenge of data privacy and ethical consideration in AI training? For you and Ludovic, who wants to
I can start. I can start.
Yeah.
I can start if you want, no problem. At Dataiku, we try to democratize the access to data and to provide anyone the ability to access data and to understand how the projects are built. And I think that's the first answer to your question, because actually the business, in my opinion, are the most accurate to understand this problem of data privacy, of security, of quality in general. They know the rules. So if they have tools and assets to be able to check and identify these rules, it's better to have a data privacy, let's say, environment. So that's the first point. The second point is governance, in my opinion. And we can imagine the governance in two ways. A technical way. So if you have private data or personal data in your data set, some GenAI algorithms, some LLMs are able to identify this and to treat these elements. So that's the first answer. And from, let's say, process perspective, it's important to put governance in all of that. Governance in terms of a process with different stakeholders from IT, from business, from compliance, that will, at the end, check that everything is developed correctly and sign off that the project can be deployed and put to final users.
Thank you very much. Maybe see for you, Ludovic. Dataiku is known for its end-to-end data science platform. Can you elaborate on the most significant advancements in data preparation and transformation techniques that have emerged to support large-scale AI model training?
In my opinion, what has changed for the last maybe 2 or 3 years, before the boom of GenAI, is that the data preparation and the data manipulation was based on structured data. So we provided users the ability to manipulate structured data. With GenAI comes a lot of unstructured or semi-structured data, like text, like images. And we can imagine that for people who are not experts, it's difficult or not intuitive to manipulate this kind of data. So what we have to provide is tools to ease the life of these users. What are these tools? Again, AI is an enabler. More and more, we see that talking in English, talking in natural language, you can transform your data. So it's the ultimate level of low-code and no-code interfaces. You speak, and the transformation is done automatically. And the other element, AI again, it's possible to automate some enrichment on data, on images, on the labeling of images and so. So at the end, what we provide to users is the ability just to check that this transformation, this automatic transformation, have been done properly. So visual interface to check that everything is done correctly. So we want to ease the life of people who are not experts in data manipulation in particular if these data are unstructured like images and text and so.
It reminds me something that I ate when I was at school. It's for those technical people in the room, it's to write regex. I don't know if you know what is it, but it's a very complex way of saying that you want to extract specific information from a text, and you have to be really, really precise. For example, you want to extract an email. That's not really easy to do. So it's always a nightmare to remember how to write it, and it reminds me that because now using LLM, it's quite easy to say and what you want in terms of, natural language is way easier. Question maybe for you, Dan. Vast data specialize in high-performance storage solution. How are you addressing the increasing demands of AI workloads, particularly in terms of data throughput and scalability for GPU-accelerated training?
Okay, so I think there's two aspects to this. There's the aspect that most people immediately think about, which is moving data to and from the GPUs really, really quickly. And so with the vast data platform, we support GPU Direct. We support that in a particularly simple way where you can use just standard NFS rather than needing some sort of custom driver that's unique to the file system. So that's good. We provide high performance access to data to the GPUs. But actually, more importantly, I think from a data pipeline perspective, which was what we're talking about here today, is the fact that we provide a truly multi-protocol approach to both structured and semi-structured data. That's another piece. And we do that in a multi-protocol manner as well. So to give you some examples, in most data pipelines, there's typically a place where the data is curated, and often that might be an object store. So sitting in an S3 object store, maybe in the cloud, maybe in some other environment. So curation is typically in one silo, an object. Then you might have some sort of data preparation. Maybe you're running Spark. Maybe you've got some data sitting in a data warehouse. You're bringing some structure to that, some metadata to that. So that exists in a separate environment and is typically separate to the object store. And then finally, you have training or maybe inference and RAG happening on data that's sitting near the GPUs in a different format again. And so what we're bringing is not just the ability to get data to and from the GPU quickly, but we actually provide a single unified platform that provides both object, data warehouse, advanced data analytics, and GPU direct support on top of that. Now that's from an infrastructure up perspective. So we provide that single unified data platform, and that provides a much better foundation. And then the data engineering problem that is still there is easier because it's sitting on that unified foundation.
Thank you. And what strategy have you found most effective in optimizing data pipelines for maybe you, Dan, and Ludovic, to reduce latency between data preparation and model training, especially when dealing with very big data sets, as we know for AI modeling now?
So from our perspective, if we look at the way that organizations have typically come to this world of training at scale, then typically you have two different platforms. You have a capacity platform and you have a performance platform. And so what we've done that's quite unique is taken a different approach that allows you to build a very large scale and high performance but cost-effective platform that allows you to simplify and unify. So we try to allow our customers to bypass that problem by eliminating the traditional tiers and silos that existed.
Okay, thank you.
Yes, to complete, I think that's a data engineer issue or problem at the end. And the most important to me is that we use the most appropriate calculation engine to perform this calculation on the data. Could be SQL, could be Spark, could be something else. The most important is to use the calculation engine the closest to the data, to me.
Thank you. From data licensing to model training, are you addressing the challenge of data lineage and provenance to ensure transparency and compliance throughout the AI pipeline? So maybe for you, Jessica.
Yeah, we take a really hard look at our library all the time to make sure that first of all, we have a very strong relationship with the contributors and the artists that are part of the Shutterstock community that add basically our data, to our pipeline. It goes through a rigorous review process that's human and AI. We also are part of, follow like C2PA practices. So we're also very transparent with with the output to make sure that people understand what content on our site is authentic versus what might be AI generated. And that also will depend on data sets that people want to license, because some want, AI generated images in their data set, and a lot of people do not. They want the originals. So we are really constantly evaluating the library to make sure that we know exactly what's in there. We also take a lot of steps to make sure that the content is really like commercially viable. Most of where Shutterstock started is with people licensing for advertising, branding. So that content really needs to be suitable for kind of a display consumption. So it's also really important that we can stand behind that content for those purposes in addition to data licensing.
And what about you, Dan? Maybe for lineage, we can think about the logs, or maybe what's going on for the processing part?
Absolutely. I think this is going to be a really important area as AI moves from really the domain of people thinking about training and training large foundational models, which is where a lot of the GPU consumption is in the world right now, to people moving across to the enterprise and using inference. So looking at the EU AI Act, if you are undertaking what the EU defines as a high-risk deployment of AI, so something which is potentially going to impact EU citizens, then, so that might be healthcare or law enforcement or something like that, then it's mandated that the user of the AI, so whether that the healthcare company or the law enforcement company, has got to work closely with the foundational model company, and they've got to show, fully document the training and the compliance throughout. So from our perspective, as somebody who's providing the infrastructure layer on which the data is potentially going to be curated, it's going to be trained, then later on inference is going to happen. What we can provide is the ability to audit and make immutable the data at various steps. So not only can you show what has happened to the data in terms of who's touched it, but you can also prove that the data hasn't been interfered with along the way as well. And so I think that's a challenge that is just beginning to emerge more as we see enterprises, including in that I mean also public organizations as well, begin to deploy AI in meaningful ways that are actually going to have impacts on citizens, on users.
On the contributor side too, we care about royalties. So we want to make sure that we also understand where the data starts and who's using it because of that, so we can make sure that we're upholding our agreement to our contributor base, that they get royalties based on licensing for data training. So that's also critical.
Maybe now for all of you, how are you leveraging automation and AI itself to improve the efficiency of data preparation and the performance of AI training infrastructure? I think each of you may have to say something on this topic, so feel free to choose.
I can start if you want. I think AI can help generating or validating data for AI, which is a bit funny. What I see is that we can use AI in terms of data quality. We can identify some bias in the data. We can see if the data are not drifting, and AI algorithms are very useful for that. We can even complete data if we see missing information using AI algorithms. In terms of data privacy, we already talked about that, but we can identify private data into a data set and decide to delete this information or change it to something more anonymous, I would say. And we can also enrich data with additional information. We talked a bit earlier about the automatic labeling of data, but we can imagine a lot of enrichment of data provided by AI to have a better algorithm at the end.
We're using AI for data enrichment very much. So for us, it's all about using AI to enhance our metadata so that the descriptions are even more complete, so that the keywords and kind of the way that people will be able to curate the data, they have a lot more options. So we're using a lot of AI tools for enrichment purposes. And then we're also using AI tools for, I guess kind of looking at synthetic versus authentic data as well. So we're using tools just in addition to human layers on that.
So from our perspective, we hold people's data, or rather, organizations use us as a platform to hold their data as part of their infrastructure. So for us, we're not inherently producing data, apart from a side use case, which I'll describe in a moment. But what we've looked at is ways in which we can enable the data platform itself to more easily allow our customers to perform enrichment in a very data-centric way. So we announced recently we're doing some work with NVIDIA to basically embed NIMs inside the vast data platform so that as data changes within the platform, some data is uploaded to an object store, a user changes some file data, we can automatically trigger certain processes that mean that the data platform itself can automatically update the metadata or provide additional insight into a validation, which might be, is this an authentic image, or has this been, does it fail some sort of scrutiny, in which case it can all automatically be taken place. As an aside, we do generate quite a lot of data as part of the logging of all of the call home telemetry, and we do use AI in terms of how we manage that. So inside Vast, we're using AI to look at predictive maintenance and things like that. But in terms of what our customers do with the platform, we're putting things into the platform that allow them to more automatically allow data-driven workflows to be embedded at the data layer rather than needing to run external services for that.
Thank you for sharing. I talked recently with Giscard, just to mention, I don't know if you know them, but they are very well known to create, because they created a library to make sure that you can do red teaming. So basically to use LLM just to make sure that you have no problem of security in your LLM application, and it uses a lot of LLM as judges. So using AI, everything is powered by AI to create such a system. So it's a very interesting topic. And about images, it reminds me something as well about accessibility. We are a bit late in comparison with the US here in Europe, but it will be soon mandatory for people with disabilities to be able to have at least alternative text for each image, and it can be done, I won't say quite easily, but we can now do it a bit quicker with dedicated algorithms that has been trained for that. So I think it's a great use cases from AI accessibility, and something that we care a lot, because I come from education background, and I think it's really worth mentioning it. So that's great. Maybe we can have another question for all of you. How do you see the roles of data creation, preparation, and storage evolving as we move towards the bigger AI models? We have heard 5,000 GPUs. Elon Musk announced much more than that. So yeah, we can see that we will get maybe bigger for foundation model in the coming years.
So from our perspective, we are already working with customers building exabyte scale systems. In fact, it's now public that Vast is part of the XAI cluster. We're not the only storage system in there, but we're the only one that's operational at the moment. And we have many other customers that haven't publicly disclosed their use. So we are seeing many challenges associated with exabyte scale data sets, both in terms of the data center challenges around the sheer amount of space you need, but they dwarf in comparison to the GPU requirements. So I think any data center which is looking at tens of thousands of GPUs, they're already dealing with the at least 100 kilowatts in a rack, many, potentially tens of megawatts into the data center. So storage is typically, the data platform is typically 10 to 15% on average, we see, in terms of the amount of data center space, in terms of the amount of power, and typically in terms of the amount of capital expenditure as well. But yeah, we're seeing some very, very big systems being built now. And it is largely being driven, going back to my earlier point, that the biggest consumers right now of GPUs are the model trainers, and they have a different set of challenges and parameters they're optimizing for than where the enterprise is. And I think the enterprise is going to have a whole other set of challenges around integrating AI into their workflows.
On my side, I will take a step aside, let's say, and talk to a collateral of this data pipeline, data creation, which is governance. more and more organizations have to, let's say, deliver some best practice and answer to the compliance that they are developing their pipelines with the best practice, with ethic, with the data privacy rules applied, and so. This is true, for instance, in Europe with the EU AI Act. And all of this process asks for a lot of documentation. And this documentation today is manual and declarative. So if in the future we can automate this documentation, it's a waste of time that is, let's say, avoid for a lot of people who are developing these pipelines.
The data curation or the data creation side, I think that we'll see more in synthetic data actually becoming more important to help supplement data sets. So I think that while the original data sets are still critical, especially at the scale they're at, synthetic data sets are going to add another level of, they could add, a diversity level that we don't have with original data. They're just another element that can help train the data. So we're seeing actually interest in that. And I think that the key to that too is a synthetic data set that's been trained on like commercially viable data. So, a synthetic data set that is kind of cleared in the same way that you can kind of buy original data. So I think that's actually the crutch there.
But content creation, it reminds me the beginning of my machine learning journey when we made very small transformation, change the angle, or we made zoom or zoom out. It was very simple transformation, but this is something now that we can do much more than that for synthetic data. And you're right. We can really make sure that some way we can just make a better balance than the real data that we have, just because we are missing some part of it. So, very interesting one. Maybe we can move to, if we look ahead a bit more, and what emerging technology or methodology do you think will have the most significant impact in the data pipeline for, let's say, 1 year or 2 years? We need to be a bit conservative, because when we say 1 year or 2 years in generative AI, it's quite a long period. So let's see.
I myself, I would say the same answer than the previous question, all the governance and all the automatic documentation of the project, which is very important in the future, at least in Europe.
Okay.
I think it was part of my answer was the synthetic data. I think it's going to be interesting in the future, and I think that again, and also like coupled with like how regulatory guidelines go as well. There's going to have to be a lot of thought put into these data sets, how they're curated, how they're originated, and I think that's going to be something that will dictate a lot of the future of the training and the baseline of the training for the foundational models.
I think, like my co-panelists, I'm not in a position to predict what technologically might be changing, but I think the big thing that we see coming quite fast now over the next 12 to 18 months is enterprise deployment of AI. And to your point, I think that one of the big challenges is going to be about the less glamorous side of things, i.e. the compliance, the auditability. And when you look at things like RAG, right now a lot of the focus, as I've said several times, is really on the model training. The people that are building the foundational models, the GPAIs, as it's described in the EU AI Act. Once those are deployed in real production systems inside enterprises, then those models are going to have access, well, assuming we use things like RAG and fine-tuning and things like that on corporate data sets, it's going to be the impact of having access to all of that data behind the corporate firewall. And there's probably, off the top of my head, people talk about zettabytes of enterprise data. So each of these AI models may have been trained on a few petabytes, tens of petabytes. There's a lot more storage in there as well, because there's things created throughout the process. But there's 1 or 2 orders of magnitude more data behind the corporate firewall. And that's both the opportunity for AI, because this is where value can be brought to enterprises by analyzing data that they uniquely have and generating the insight from that. But the challenge is going to be fixing all of these problems that we've been talking about around compliance and even internal access. You know, different groups within an organization may not have the right to train on all of their organizational data. And those are challenges that the world hasn't really been thinking too seriously about so far, in my opinion.
Exciting time ahead. I mean, we have plenty data more. We can create nice things, so that's really great. I think it's very close to the end. We have 1 minute, so maybe what we say, a final word or something that you want to share or a key message that you want to give. I don't know if someone wants to start.
No, not specifically. On my side, as someone from Dataiku, I would focus on providing the most possible capabilities to end user, to business user, because it's important to involve everyone into this kind of process. And I would add also governance, which is very important as well.
Governance. Jessica, do you want to add something?
Yeah, I think on the data creation side and kind of data acquisition side, you know, we care about both supporting our end customers, our technology customers, but we also take a lot of pride in supporting our artist customers and our creators. They're the ones that are kind of supplying this data that we're going to build on top of and create, you know, all these creative, imaginative products on. So we're thinking a lot about that end-to-end process. And so making sure that we acknowledge where the data begins and where it's ending, and that everybody in between is kind of being appropriately credited, compensated. That's important to us.
Dan, one word. After Scaleway will be very mad at me.
Well, my recommendation would be ask ChatGPT to summarize the EU AI Act for you and have a read of that, because it's quite eye-opening.
Okay, thank you very much.
Thank you. Thank you very much, Jessica, Ludovic, Dan, Paul. Thank you. So we will be back in 5 minutes for our next session about AI investments. So I'll see you shortly, 2:35 sharp. Okay, welcome back to the central room. So, welcome for people who come in the room, for people who stay, thank you. Online, thank you for being with us. Next up, we are exploring the financial forces behind AI on how to approach AI investment. So, let's jump into investing in AI, builders versus adopters. Please welcome on stage Gabriel de Vinzelles, partner at Frst. Alexis Robert, partner at Kima Ventures. Rana Yared, general partner at Balderton. Paul Murphy, general partner at Lightspeed Venture Partners. And this session will be animated by Julien Codorniou, partner at Felix Capital. The floor is yours.
Is it working? Yeah, perfect. Thanks for joining us. We know you're very busy. We know you had many other options, so we appreciate that you decided to spend the next 30 minutes with us. We're going to talk about venture capital investments, startups, AI evaluation, many things. But maybe to kick things off, I'm going to ask you to quickly introduce yourself, who you are, who you work for, and what your AI credentials are. And I'm going to start with Rana.
Hi, I'm Rana Yared. I'm one of the general partners of Balderton Capital. We are a 25-year-old venture early stage and venture growth investor out of London. Our credentials go back about a decade with our investment in Magic Pony that then became the engine that powers the Twitter algorithm. We followed on with the implementation of AI and security with Recorded Future. Then Wave in autonomous driving, which used the first instantiations of computer vision. And then most recently, we have made investments in Writer AI and DeepSet out of Germany. Thanks for having me.
Welcome. Paul.
Paul Murphy. I'm a partner at Lightspeed. Lightspeed is a Silicon Valley fund, been around for similar amount of time, actually. I moved over to launch a Europe franchise. Before Lightspeed, I was the founder Lightspeed invested in, and then ended up on the other side of the equation. Also started a company, an AI company that Kima invested. So I've some experience as a founder. As an investor, led the round in Mistral, and sit on the company's board. But as a firm, we've got just over $1 billion, 1.8 billion, it's almost $2 billion now into AI, about 85 companies, including multiple foundation models and kind of everything in between, including life sciences. So we've done and seen a lot, I should say.
Alexis, go ahead.
Hi, I'm Alexis. I'm a partner at Kima Ventures. Kima Ventures, we handle the business angel checks of Xavier Niel. We invest in 2 queries per week, checks of 100 to 150K in French companies based in France or French co-founders abroad, and in pre-seed. And me, myself, I was a software engineer. I started coding when I was 8 years old. Then I lost myself. I created some companies, some startups in 2010, 2013, and I crashed all my companies. I'm a very bad founder. That's why I became a VC, because people that don't know how to build advice. So I became a VC in 2015.
Alexis, any AI companies in your portfolio you want to mention, or you're in every AI company created in France?
We are in nearly every company in France, but Xavier is an investor in Mistral, Poolside. I can make the list, but it will be very long.
Perfect. Gabriel.
Yeah. So my name is Gabriel. I work at Frst. Frst is a day one investment fund. That means we invest before product launch, before metrics, before product market fit, and everything else. We write checks up to 5 million euros. 90% of our investments are in France. I've been in the fund for 8 years. That's like basically all my career. And my AI credentials, we are first check investors in a company called Poolside, which is a code generation LLM company. We are also in Oakin, that creates drugs thanks to AI, and that recently spun off a company called Bioptimus, which is a LLM for bio. And I think that's all.
Great. And I'm Julien. I became a VC 3 years ago, joining Felix Capital in London. And before that, I was an operator. I spent 11 years at Facebook and 6 years at Microsoft. And I invested in companies like TechWolf, Pigment, Nabla, and a few gaming companies. So the big debate in VC right now is, should we go horizontal AI or vertical AI? How do you approach that problem? And how do you think of these two opportunities? What do you see the best possible deals and the best possible outcome? I'm going to start with you, Paul, because you did one of the flagship horizontal AI deals with Mistral.
We did, but we also have done a lot of vertical solutions. I think the way we view it is the sort of pros and cons are maybe simplistically you can generate quicker revenue and faster, find product market fit maybe a bit faster with a vertical solution. But some of the best vertical solution companies in software and tech have started out that way and then built horizontally over time. Famous examples being Amazon, but also Stripe and Palantir and many others. So I think my kind of, when I put my founder hat on it, I think, what's the fastest path to product market fit, whatever that might be. In some cases, it may be something that's more of a platform product and then you can sell it or have developers use it. But I think you want, as an early stage founder, I would say you at least want that signal. All we look for is sort of stage appropriate signs of life. So if it's a seed company, mostly a founding bet. If it's later stage, obviously we're analyzing the traction and the revenue.
Rana?
Yeah, I'm largely on the same page. I'd say stage appropriate signs of life plus no signs of potentially terminal diseases. And I say that as a joke, but in the previous panel, one of the gentlemen was talking about how there's going to be cajillion bytes of data that are created and compute power that can shut down the EU and being hyperbolic on purpose. That's actually problematic, right, from my point of view, because it opens questions as to whether the model of the underlying horizontal companies actually can grow to meet the demand in the world that we happen to live in. And so when we look at horizontal and model generation, we're very much focused on companies that have the capability to provide excellence and accuracy without needing huge amounts of compute power, and not meaning to be a plug for one of our portfolio companies, but that's kind of the mindset of the CTO at Ryder, and he's managed to do some pretty incredible things with very large models, but very little compute power. So that's on our mind when we think horizontal. And then vertical, it's really a question of is the business big enough? Is the area big enough? So great example there would be, AI used in industrials or AI used for automated driving. All of these are big enough verticals where you can tackle them and have, to use Paul's words again, stage appropriate signs of life that tell you there's a really big company that can be built. But the danger with verticals being too nichey, if I could put it in those words.
On my end, it's very simple. It's about building startups is about making things people want. So rather it is horizontal or vertical. To be honest, the most important is making things people want and having product market fit. The other aspect of my answer might be also that when you're too horizontal, a lot of time we see in companies that they tend to have vertical GTMs inside of companies, because to be able to tackle, you're so horizontal, but sometimes it's tough to get customers if you have this horizontal narrative. So you need to find some vertical narrative or vertical GTM or vertical sales team or either sales pods or marketing pods to be able to handle the different customer segments, because otherwise you lose yourself. So,
Alexis, can you give us an example of a company that just did that?
I know, so I don't know for sure, but one thing I heard is that Airtable really blew up when they started the templating system, because the problem of Airtable is that they were very, very generic, so people didn't really know what they could do with Airtable. And when Airtable created the templating system, they had templates for every use case, so people can emphasize with the different use cases. So even when you're horizontal, you need to have a vertical element, otherwise you lose yourself.
Gabriel, vertical or horizontal, and why?
I would say both. So as a pre-seed investors, my job is to find teams but not themes. So we back founders and they find their way to product market fit. Now that I say that, I think that it's about picking your poison. If you go vertical, you have a market size problem. If you go horizontal, you have a distribution problem because it's harder to find a client efficiently. Now maybe AI changes this framework, because vertical markets are composed of how can I say that? With AI, you don't sell productivity software, you sell the work. So maybe smaller vertical can provide bigger markets. So maybe that changed the framework of vertical versus horizontal.
And in terms of pipeline, do you look specifically for native AI companies, or is there AI in every company you look at these days? Rana?
There will be AI in every company that we look at eventually. So from the Ballers end point of view, we're going to think about AI at some point the way we think about cloud. Every company will take this next generation of technology and implement it in the appropriate way for its business. And to not do so would be the same as having missed the entire movement to cloud. So eventually, everyone. And in the meantime, application layer is very interesting because it enables the most people.
Is it the same for you at Lightspeed, Paul, in the late stage category?
So across later stage, I would say no. But early stage, I would say that it would be the exception for us to not invest in an AI native company today. Actually, even going back the last 3 years, it really was the exception. I think we had sort of assumed that any company that had been built kind of in a different paradigm really had to go through its own version of a company pivot to be relevant for the next 5 or 10 years, which is the kind of investment horizon that we typically have. So I'd say we're probably maybe a bit, there's not many things we can do as a fund to really restrict our funnel. We look at every stage, every sector. We'll do robotics, life sciences. But I'd say AI is probably the one filter that we do apply to our pipeline.
What about the early stage investors? Is every company you talk to a native AI company these days?
Yeah. To be honest, yes. As I mentioned, we are looking for founders, and I think at the moment the best founders are using this magical technology to rebuild existing software categories. And out of the 10 last deals we've done, I think 7 of them are AI native companies.
On our end, it depends on your notion of AI companies. It's, to be honest, as I mentioned earlier, the most important thing, something for you, like we invest in teams and we invest in people that make things people want. When you look, for instance, AI is a technology that is there to enable use cases. The end customers, they purchase the use cases. They don't purchase the technology. For instance, if Uber Eats is based on PHP or Python, you don't really care. You don't go on Uber Eats because it's a Python-based marketplace to buy pizzas. You go to Uber Eats because you're hungry, you want a pizza, you go to Uber Eats, you have your pizza, you're not hungry anymore. And if Python helps the user to have a quicker pizza, that's what they purchase. Like if they use AI because it enables new use case and it's changed their world, that's exactly what they purchase. So most of our companies have an AI angle because it's a new technology to program and to develop code that enables new use case, and it's essential to have an AI element when you're building a software now. But if you use this, yes. But otherwise, it's like we see it's mostly like a traditional company, to be honest.
Let's talk.
If you'll allow me to introduce a bit of friction on this point. I'm not sure that companies have to take a pivot in order to implement AI. So, easy example, lending company. Lending company has been lending for 7 years. They've done their underwriting the way they've done it. They've done their back testing the way they've done it. AI now lets them do it better. They haven't changed what they fundamentally do, but they've taken that step function to do it better, faster, and ideally cheaper. And there's a whole lot of companies that you wouldn't classify as AI native that are going to implement in a way that will determine whether or not they have durability in the next step, but they don't have to change their fundamental business to do that.
Like Klarna, who improved their gross margin by implementing AI in the support center.
Great example.
I think that's valid, and it's a really good point. I think the way, maybe the reason I think about it this way is if I just take a company like Salesforce, they're doing $40 billion in revenue, roughly. And then you've got the sales industry, it's $1.5 trillion. So I think that there's going to be great companies that will continue to survive and maybe even do really well without kind of an AI native approach. But I think what we're interested in is finding those companies that are going after the sales industry, or take the services industry, the big four, it's, a couple $100 billion. dollars of opportunity that, in my view, is completely up for grabs. And so you've got these very, very, very large markets that are going to be opened up and I think taken within the next 5 years. And that's kind of what we're looking for. That's probably why we're a bit more restrictive.
So let's talk about valuation. We've seen the public valuation of companies like Mistral, Poolside, that you guys have funded, Photoroom, I think, as well. We've seen the multiples. How do you price these AI companies, especially these flagship AI companies in France? How does it work?
I'm happy to start. So
start with the late stage VCs and then the early stage VCs.
I mean, we are, we do have a large late stage fund, but we are early stage investors. We led the seed round in Mistral, even though it was a large seed round, it was still a seed round. And I think that the way that valuations have always kind of developed is you look at the scarcity. How many people do we think realistically can do what they're trying to do? How big do we think the market could be? In the case of Mistral, it was relatively simple actually. We had, like I said, been investing in this category for a very long time. We knew about 100 people in the market that we thought we wanted to do something with. These were 3 that were on that list, very high on that list. And what they wanted to do, we thought made a lot of sense, especially for Europe. And so we felt if there's one team at that moment that could do something which could potentially challenge the other big models, this is it, and we made that bet.
Generally in pricing, AI or otherwise, you have to price commensurate to the opportunity. And you don't want to sacrifice accuracy, being in the right name, for precision, trying to get exactly to the right number that you think that you should pay. So I think that applies to AI and it applies to everything else. Your question has a nuance to it, which is also why in Europe. And part of the reason why the valuations are what they are here is scarcity. So not only are all of us as European investors looking at the best companies here in Europe, but when our American brethren, or actually those physically in America, since I'm an American, brethren, look at the deals in the US, and let's say they miss a deal in a subject area that they care about, they get this fear of missing out, and then they start looking around the world. And then they look into our pool. And so not only are we all investing at the stages that we invest in the European pool, but all of the Americans, when it comes to AI, when they lose a deal there, are also looking to bid up the deals here. And so it's that combo that's creating, I would say, the extra tension around pricing here.
How does it work at the seed and pre-seed level? Has AI changed the multiples, the methodology, or is it just like it was 2-3 years ago?
It's a question of, it's the same answer. It's a question of market. Is that when there is more demand, it's a question of demand and supply. We want to do deals in AI because it's a transformative industry, and we want to play rather than sitting on the sidelines. And to be honest, it's a question of demand and supply constrained to the different quality of companies. And then you can ask yourself, yeah, but the problem that doesn't the valuation make sense because, okay, there is demand and supply, but sometimes it's too expensive, you will never make a return. There is a podcast that is super interesting by Doug Leone of Sequoia that talked in Invest Like the Best, it was a year ago, and they talked about this subject of is AI a bubble in valuations or not? And he said something that is very interesting. So it's also because the size of the fund of Sequoia is super large, so it applies mostly to them. Smaller funds is different. But when you looked in the bubble in the year 2000, okay, so 90% of the company died, or 95% of the company died. But out of this, there was Amazon, there was Google, there was a lot of huge outcome. When you're a fund like Sequoia, that is a very large one, you need to play because you cannot miss the next Amazon, you cannot miss the next Google. So you need to play, and you prefer to pay to be in these deals, even if it's a little bit expensive, because your upside is unlimited, and you're not really sensible to the downside because you have a very large fund. So it's a question of market, a question of fund strategy, and so as a fund strategy, we need to play, and we want to play, so we participate in these deals.
Yeah, nothing much to add. I guess it's a strong demand, small supply, plus a very strong rationale from founders about the size of the market they are absorbing.
Just one quick point. I think that's relevant for people because we've started seeing this recently. I'm not sure if you have as well, but a lot of really great AI teams that got seed funding are now coming back to market, not necessarily with the sort of traction you might expect, but they're saying we need to raise $20, $30 million, and why do you need to do that? Well, we have to get these AI scientists out of Meta and DeepMind, and they're on $1 to $2 million retainer packages. And so it's very expensive. And that, I would say, even for a large fund, is very difficult to underwrite. And so I think maybe just thinking ahead a little bit on kind of your growth strategy for talent is really important in AI.
But applied to the French ecosystem in particular, when people invest in Mistral at 5 billion or Poolside at 1.4, I believe, even a company like Pigment, and as VCs, we have to be optimistic, otherwise we would not do that job. But we hope that a company will come and buy these companies for a multiple of what you just paid. So in a way, we all hope that something will happen in France that never happened before, which is a 10, 15, 20, $30 billion exit. What gives you that confidence that something like that never happened will somehow start happening in Europe and in France in particular?
We should feel really good about that in Europe generally, right? So I'll take a non-AI pivot and come back and say Klarna, Stripe, Revolut, Monzo. We now have a very substantial number of names cross-industry that compete with the US on size, and the more of those you have, actually the more of those you get. So it's very positive. On the AI side specifically, Paul said very nicely that Mistral is the European company that meets the moment for Europe, but I think it also meets the moment for most of the world except for half the US. And it's true. And so there's really an opportunity there for a particular paradigm of purchase, but it is all ultimately contingent on having real product market fit, a deep market, and then revenue. Because whether it's the public market or a public buyer, you have to show value to the public purchasers.
Gabriel and Alexis, as early stage investors, do you sell when you see the big bucks coming and the big valuations coming, or you also hope that something amazing will happen to your companies, even if it takes many, many years?
So I'm an advocate in the fact that VCs are very bad sellers. So, so because there's a lot of psychological elements that are there. Yeah, like in casino, you're playing, it's your best outcome. Do you sell? Don't you sell? And stuff like this. You tend to hold a little bit too much. So yeah, I don't know how to answer this answer because we are in general, I think we are bad sellers.
And you stay as long as possible.
Yeah, also it's also the philosophy of Xavier and what Xavier wants. We want to stay as long as possible as a fund strategy.
Yeah, we are holder in all our companies, and they are quite young companies. So, yeah.
It's true what you said, though. The saying is that we are great investors and terrible portfolio managers.
Yeah.
That is
some are bad investors and bad sellers as well, but
I think you're going to see functions starting to form at some of the larger funds that actually think about that question, because as companies stay private into the hundreds of billions of dollars, I actually think it's poor financial strategy to just hold forever. But getting out and when to get out, it's all science. I have no idea how to do that well. I will say, though, when we think about exits, and Rana sort of mentioned this, and certainly with the new U.S. administration that you have, I think you're going to see America become much more insular. It's been telegraphed in the policy. And on one hand, you might say, well, that's bad for European tech because potentially it might be harder to get deals done or it might be hard to win in the U.S. But I hope that this is a moment for Europe to actually build companies that can really own the market here, become large, potentially go public within Europe, or even be bought by large European companies. I think that is an opportunity that we should sort of take advantage of. As an adult that's been in Europe most of my life, I hope that's what happens, at least.
Let's talk about competition. So we now have a few flagship AI companies there, in France in particular. We mentioned Mistral, but we also know that OpenAI is coming. I think they're opening their office next week. People at Nabla have been competing with Facebook forever to attract or to keep their best talents. How do you see that competition between big tech or emerging big tech from the US with unlimited money and the local players, VC-backed, who do want to compete for talents, for markets, for deals with these American companies? How do you think you can win there? Rana, you seem inspired.
Happy to. It's a mindset issue, right? So do you want to be employee number, fill in the blank, at big tech name, fill in the blank? Or do you want to be at the ground level doing something groundbreaking at a company here? you just have to ask that question of the employee base. Some will break in one direction, some will break in another, but it's incumbent on startups like those in the room, their investors, us, to help refine that message that makes it clear that there's something incredibly attractive about not being the 3,000th employee.
And it's an equity issue at the same time.
Yes, it's a proxy for, exactly.
In which
yes.
way, Gabriel? Can you elaborate?
If you get 1% of a pre-seed company joining them when they get started, you can make a lot of money, way more than working for a huge salary in a big tech.
And on the science side, I feel like in AI especially, the questions at least that I feel people are asking is where can I do the most groundbreaking work? And I know that there are multiple examples of European companies that have turned down acquisition offers from the larger AI American companies because they didn't feel like that environment was going to be conducive for them doing their best work or groundbreaking work, and they'd rather stay with the European research organization.
Which is good news for everyone.
Yeah, and that's the thing. Like I remember, like when I was doing my second startup in 2013, like that crashed. And like at the time, like in 2012, 2013, every investor, every person, were always telling, yeah, what if Google does the same thing as you? What is like Facebook doing the same thing as you? The thing is that actually, it was the number one question you had in your FAQ when you tried to fundraise. The thing is that they never did the same thing as you, and Google tried to do a lot of different projects, and a lot of them crashed. And why? Because like large companies are slow and political, and startups they don't have but they have a cash. So large companies have a cash, but they are slow and political. Startups, the advantage of startups is that they are quick, they are fast, they are hacky. That's why we bet on startups. We invest in startups because they are quick, and speed of execution beats cash and politics. That's it.
Regulation. How do we make regulation in Europe an opportunity versus a challenge? And I know some of your companies have been very vocal on that topic. But any asks or recommendations?
I mean, I think going back to my previous point about the US becoming more insular, more protective, I do think regulation has many drawbacks, but European regulation is becoming fastly viewed as the standard that's being adopted in other markets around the world. So I think if we can view, I'm not saying this is happening, but if we can view regulation in Europe as potentially a template for the rest of the world and design it with that in mind and an opportunity for us to lead from here, I think that's not only good for the companies in Europe, but also for the importance or presence of Europe globally.
And I think also the right regulation can be a stimulant for actually the adoption of AI. So we think about like large enterprises, maybe like the one I used to work for. I was a partner at Goldman Sachs before. Banks, healthcare companies, any other regulated entity, they really think very hard about where their data goes and how it gets used and what are the guardrails around that. And if there can be sensible regulation around the guardrails that has to be implemented by the AI vendors that the large enterprises are going to purchase, then those enterprises are more likely to actually make those purchases, and they are both the biggest and the stickiest clients that any AI company that's selling into the enterprise is going to meet, and they meaning healthcare companies and financial services. So it can be an enabler for the whole market if it's constructed well.
But the plan for you is to keep investing in Europe and in France.
Yes.
Gabriel and Alexis, how do you?
On your last comment, I think we really want to push our founders to build US-centric companies, so roots in Europe but business in the States, that will help them build category-leading companies and remain relevant and competitive. This is our way of viewing it, to be honest.
Our opinion is that like the goal of a founder is to find a way to get from point A to point B in whatever means possible, and it's always the thing. You have a yellow line. You need to play a little bit with the rules. You need to play in some way to be creative and find solution to get from point A to point B. That's the founder and hacker mentality. And when you see, for instance, in fintech, for instance, where you need to have a lot of regulation, you need to have like you want to be an insurer, an insurance product. Before you needed to be a full insurer, then we found ways around MGA and some other licenses. And the first insurtech that came in Europe, they found ways to hack a little bit with using a different kind of scheme and stuff like this. So we don't really look at the regulation angle as an investor, as a pre-seed investors, because we invest in great teams that have like this hacker mentality, this hacker mindset that makes things people want, and they will find a way. If it's like to relocate in the US, to do business in the US because they don't find a way, maybe they will find they will find a way.
There's a real risk on that strategy for Europe, right? So if all of us, so Balderton is predominantly a Series A investor. If all of us in the seed and Series A, we're advising our companies to eventually like recenter their businesses towards the US, then all of those amazing exits are US exits to US markets. All those founders, make their money in the US and reinvest it in the US, and we're like naturally draining the European ecosystem. So, where appropriate, where our companies are meeting clients that require them to be in the US, we obviously ask for a presence there, but we think it is really important to keep companies here, not least of which the talent is cheaper because there's a third of the world's engineers here, and the path to 100 million of revenue is faster and cheaper in Europe than in the US.
Especially that you enter in more risks of having your M&A deal blocked.
Yes.
Great. I think we're running out of time.
Yes, thank you very much, Gabriel, Alexis, Rana, Paul, and Julien. Thank you very much for your insights and your time. So don't go too far. We will take a short break. We will be back in 4 minutes, 3:10 sharp. Next session about AI scaling barriers in healthcare and biotech. Okay. Okay, welcome back. Welcome back to Central Room. Our next session, we are going to address a particularly challenging topic: overcoming AI scaling barriers in healthcare and biotech. So this session will highlight the unique obstacles and breakthrough when scaling AI for those critical sectors. Please join me in welcoming our speakers: Julien Gimbernat Mayol, Head of Product for Deep Chain at InstaDeep; Jean-Philippe Vert, CEO at Bioptimus; Robert Marino, CEO at Qubit Pharmaceuticals. And this panel will be animated by Chris O'Brien, founder and editor at the French tech journal. Thank you.
Hello. Well, can you hear me? Yep, there we go. Well, welcome everybody. We have a short period of time and 3 excellent guests. You've got an introduction, but I just want to take 1 minute and go through each of you and just say, introduce the company a little bit. What is the mission? What is the problem that you're addressing? And Julia, we'll start with you.
Yeah, of course. Hello, everyone. It's great to be here with everyone and these great speakers also. So I'm Julia. I'm the head of product for Deep Chain at InstaDeep. And what InstaDeep does is create very valuable AI solutions for decision making across 2 main verticals. One is the industrial optimization vertical, which is more on the reinforcement learning side, operations research, and the other one is more on the biology side. So we work closely with biotech and also other external biotech partners. And I'm leading the product for the bio side. So essentially all the research that we do, which is super cutting edge, super great papers published in great journals in machine learning, deep learning, how do we bring that to the application side, to the users? And so that's what Deep Chain is. Deep Chain is bridging the gap between these things. And the problem we're solving is basically deploying these AI solutions end to end in the immunotherapy pipeline of biotech and other challenges.
Great. Jean-Philippe?
Yeah, sure. Good to be here. My name is JP. I'm co-founder and CEO at Bioptimus, which is a startup that was created end of last year. We came out of stealth this year. What we do at Bioptimus is build a foundation model of biology overall. So foundation model means like a computational model of biology that allows them to do simulations, inference, etc., to solve tasks such as drug discovery, diagnostics, etc. Myself, I'm a scientist. I've been working the last 25 years in AI and biology, first as a professor, then at Google, then at Hawking, and at Bioptimus.
And Robert?
Hi, everyone. I'm Robert, CEO at Qubit Pharma. We discover drugs, so we do small molecules. We have currently 7 drug discovery programs running in oncology and chronic immune disease. To do so, we use our platform that blends AI, high-performance computing, and quantum. And our mission is to work on very complex targets. So targets in the human body that are considered way too complex to be treated with other types of technologies and managed by other types of technologies.
Great. So we've heard a lot of talk already throughout the day about data and AI. And of course, we know all types of AI require very precise, very large amounts of data. We want to get into, particularly now with the biotech and the health field, how that looks in this sector and what that means in terms of scaling. So JP, let me come back to you on that question. For Bioptimus, what are kind of the challenges there in terms of the data and scaling up with that?
Yeah, thank you. So great question. So, I was quite general saying Bioptimus is about foundation model of biology, and biology is a broad term, right? It goes from molecules to cells, patients, ecosystems, etc. So we're quite ambitious about training models that understand biology across the scales, so from molecules to cells to organisms, etc. And of course, because it's data-driven, it's AI, we need data at different scales and with different modalities. Okay, so the needs of Bioptimus in terms of data is massive. We want to train one model to summarize all biology, because this is what we need to then answer questions like, if you change a molecule, how does it impact the patient, for example? Okay. The data themselves, I think in our space, there are basically 3 sources of data that you can think of. One is there are some public data for some of the modalities. For example, there's lots of DNA, protein sequences publicly available on the web because there's been massive genomics program that led to public data. Then the second source of data is data you generate yourself. So at Bioptimus, we are very young, but we will one day have wet labs probably, or work with wet lab generator to have data you generate. This is your own. But then the big amount of data, which is our focus today, is all the data which exists and which is not public. And the data is in hospitals, is in companies, etc. So this is where the complexity of the data acquisition is, because if we talk of medical data, for example, for many good reasons, they are not public, and even if you agree to access them, there are lots of regulatory constraints. So, long story short, we have different technologies and approaches to be able to, partner with different stakeholders. That could be labs, that could be hospitals, that could be companies, and the two sides of the two important aspects to negotiate such deals is, well, first to find a win-win situation. So, for example, when we want to work with hospitals, they're not here to sell data, but they're open to collaborating if we bring value to them, to the patients, etc. So there is a question of finding the good incentivization to be able to agree that we can work together. And the second is a bit more technical. You need to provide security of data. You need to provide traceability. You need to provide anonymization, etc. In a sense, and I will let my colleagues speak, but in a sense, because we work on foundation models, we need a lot of data, but not necessarily annotated data. So this means, for example, when we train a foundation models on images of tumors, we typically negotiate partnerships where we want to have access to large amounts of images, but we don't want the metadata, right? So it's very easy to anonymize, I would say. We're in a business where we don't want to make the connection directly between a raw image, the clinical state of the patients, etc. So that makes our life, I would say, a bit easier than if we wanted to have access to all the medical record of the patient, etc. Because then you would enter into a different space, which is you need to respect privacy, to be super stringent on how you handle the data, etc.
Great. Julia, let me jump to you. How does InstaDeep look at the question of data and modalities?
Yeah, of course. So I like how you put it, GP, in terms of biology is a very broad term that has like so many data modalities, so many complexities in it. And of course, this idea of there's a biological process, and if you can look at it from different dimensions, different data modalities, different technologies, ideally you can explain really well this process, and you can have a good understanding of it. And the way InstaDeep is tackling that actually is going one data modality at a time. So for example, if you want to explain a process that includes genomic data, protein data, histology, all of these different types, you ideally want to go one at a time. And we started at InstaDeep with genomics. And maybe more on the technical side, what's really interesting about taking it one at a time is that these complexities in biology, you can try to understand them by understanding the data generation process. So that's a really great advice I once got from one of my mentors, which is like, if you want to build a good model, of course, you have to understand the data really well, but understand it to the point where you even know how the technology generated the data. And the example I have for you is sequencing data, for example. I don't know if most of you have heard of the sequencing by synthesis, where you actually, to read DNA, you can't like read end to end. You have to sort of generate these smaller sequences we call reads, and these are like 100 to 100 base pairs. Base pairs would be, if you imagine DNA being a language, you would have like letters, like you would have ACTG, 100 to 200 of that. So ideally, you generate these sequences, and then you align them to the reference genome. And at the end, you see these kind of fragments being aligned to the reference genome, and then you see regions which you see really good coverage, you see really good depth, as in you see lots of these fragments being aligned, and other parts where you don't. And that really gives you, if you understand like this kind of generation process, you see how you can be very confident of what you're seeing in this biological process in parts where all of these fragments are aligning, whereas in other parts, it's way more difficult to actually see what's going on in this genomic data. And so I think it's really important to understand these kinds of things, because then when you build models and then you consider every part of the genome to have the same kind of confidence in that it's read what is really in the sample, then you really have to consider where it came from and maybe put more weight in the things that have more confidence compared to others. And I think that's something that's really special about biology, where each modality will have its own things, its own ways to generate. and you really want to make sure you integrate that knowledge. You have someone in the room that has like the bio hat, someone like JP, I'm sure you have the AI hat, the bio hat sometimes. So you really need to know how you can, put the bio hat on sometimes and then jump to the AI research hat and combine the two. So that's, I think, one of the key things we do at InCity.
Great. Robert, let me come to you now. Obviously, with the name of the company, people think quantum. And I know we've spoken before, you're more than that. There's a hybrid approach you're taking. And you've also talked about this idea of the challenge of the quality of the data, and you are using your two platforms to manage and create synthetic data. So can you talk a little bit more about both the quantum and the AI aspects, but also how you're building the platforms to deal with that question of data?
Sure. So just to give you a few numbers, so we intervene once the biology is solved. So we work on proteins, we work on RNAs, where people have clearly established that if that protein malfunctions, there is a disease. And then we have to find a small molecule that will reestablish the properties. When a pharma works on such projects, the pharma will generate about 5,000 to 10,000 experimental data points. These points will have certain features that are measured experimentally, but the more you advance in your drug discovery programs, the more features you look for. At the beginning, it's 1 to 2 features, and then you retain or discard the value, and then eventually there are about 30 features that you look for. So your database will evolve over time. At the beginning of your project, it's very poor data sets, and then eventually very good. So you will have probably 200, 300 points that are fully characterized, and all the rest with poor characterization. And these data sets, they are closed, so nobody can get access to them. Only within big pharma, they don't share it, and so on. So doing big data on that, or even just data mining, is quite complex, because getting access is complex and sharing is complex. So we do have developed a platform that allows to predict these properties computationally. Now, we're facing a problem that the platform is very efficient. So instead of doing the synthesis and testing, we can discard about 95% of the compound. So instead of these 10,000 molecules, we'll probably get only 250. So how do we build a platform and mine data when the best, the more accurate we are, the less experimental data we get. And that's how we bridge the gap with synthetic data. So we try to build physics models that are highly accurate. By highly accurate, we mean that when we compare the experimental value with the computed value, we fall into a region where it's impossible to differentiate computation and experiment. So it's always a benchmark. You don't need to have the exact value, but you need to be below the experimental error. And one way to generate this data is leverage quantum computing. So quantum computers today, they are still prototypes. Government buys some of them for research, but they are maturing. 5 years ago, it was an idea. Now you have a couple of quantum computers in each country, and every year they go much more than twice computing power increasing. So we developed the algorithm so that we can generate very good data, but it will be small data sets. But these data sets fuel our neural networks to then do better predictions. So it's a full pipeline that we build from quantum generated data that leverage hybrid neural network, and then accelerated by high performance computing.
So let me stay with you then for the next part of this conversation, getting a bit more into the scaling part. So you have this foundation, you have these tools, the data, the problems you're addressing. What is the challenge? What are the big challenges then in scaling that up? Is it the computing power? Is it getting more data, or what are the big barriers in that dynamic?
One of the largest problem we have right now is about experimental validation, surprisingly. As we work on what's called novel and complex targets, such as RNA, for instance, we don't deliver vaccines, but with small molecules we target RNA, which is a quite new field. We need to have some experimental validation, and these tools, they do not exist. So right now, one of our major focus is finding the right partners, or even investing into new experimental modalities to characterize the data that we are generating. RNA is one example. We have other types of examples that, thanks to the platform, we can now address. But because it was not a focus of interest for big pharmas in the past, because it was too complex, there were no tools, we have to develop the new tools. And that's probably one of the key aspects, which goes back to what you just mentioned about how do you acquire the data. On one of the programs, we had a strong discrepancy between theory and experiment. Like nothing worked. And then we found out that we were not comparing the same features. So the theory was measuring something and we were comparing something else. So you can spend 6 months on that. If you don't have the experimentalist talking to the computational team, you will never get the results. So that's very important to bridge that gap, having people that generate data talk to the people that use that data to generate novel outputs.
And JP, same question then. I mean, obviously you've got this great foundation. You've got the dynamic, the data coming in, the models building up. Then scaling that on a massive level, maintaining accuracy, continuing to fine tune it. How does that work, and how do you address that challenge?
So I think there are quite a few ways, but maybe I will just insist on one or two. So one is as I was trying to explain, we train a model with different sources of data, molecules, images, genomes, many things. So we do that for two reasons. One is, as I said, because the problems we want to solve require us to understand the link between molecules and patients, etc. But two is also because we know that for each modality, there is a limit in the number of data you can have. Sometimes the limit is higher, but as soon as you talk of patients, there are not billions of patients for which so there is a limit. And the idea to use different sources of data, different modalities, to us is a way to keep scaling the models by saying instead of having more data of one modality, can you cross it with other modalities? And here the crossing we do is something that is very different from what standard multimodal foundation models do, because we're crossing data that are not aligned at all. Like suppose you have 1 billion protein sequences that exist, and you have 1 million images of tumors. How do you train a model jointly? In fact, it's possible, but the link is a bit subtle. It's not as if there were two views of the same thing, because we're talking of proteins and of patients. It's very different. But there is a real link that exists, which is that the proteins are in the cells of the patients, right? So what we do to manage to benefit from the volume of data together is to build specific architecture, actually. So we build specific foundation models, specific attention mechanisms, specific things, so that we can jointly learn from data that look very different from each other. But when I say look, we know this is all about biology. We know there is a link, so we try to model the link that we're aware of in the architecture of the model so that we can jointly train. So maybe I'll stop here, but that's one way to scale it by increasing different modalities and making them talk to each other.
If I can just ask one clarifying question. So in terms of the structure of the models, until this point, you've been using sort of the classic, well, I hate to say classic, but the sort of general structures, but now you need to move to a new structure that's more specifically designed from the bottom up for biotech, for health.
Yeah, exactly. And so, for the tech audience here, when we talk of multimodal foundation models, like text, image, speech models, there are different architectures, but more or less at the end, it's about saying all of these modalities, you can map them to the same dimensions, right? And they can be all put in the prompt, and then you can combine all of that, because a text, an image, a speech describes the same thing from different viewpoints. For us, indeed, we need something different, because you cannot mix one protein and one patient, right? It's just different. So the architecture is different, is new, it's more hierarchical transformers, it's more specific attention, etc.
And then is it, with the new models, is it clear how, again, you will scale them in terms of maintaining accuracy and keeping them tuned? And
yeah, so we see that doing that is a way to really boost the accuracy. So for us, this is one of the ways to boost the accuracy of foundation models, which is different from just having more data of one modality. Now it's about having a more complex model that benefits from different modalities. And then there are technical, so as you can imagine, it's not easy. I mean, because we're talking of new models. So, transformers that many of us use, they work well because you have thousands of engineers in academia, in big companies that have, optimized them, right? When you're new and you say, well, I need a new model, which could be quite different. Well, even though we have a fantastic team, let's say it takes a little bit more time, it requires optimization, etc. So at least we see big progress. Between 6 months ago and today, the progress are very, very quick. But there are technical challenges. Yeah.
Okay, I'll stop picking on you now. Julia, same question, obviously different approach
Sure.
than Bioptimus, so different challenges, I imagine, for scaling and overcoming those hurdles.
Yeah, of course. The way I think about scaling is, the scaling laws state that as you increase the amount of compute you have access to, the amount of parameters of your model, and the amount of data you have access to, you can ultimately gain performance gains even without changing your architecture of the model. And so I love that Robert and JP covered all the data hurdles that I was thinking about in my head, like the aligning, you have different data types, but they're not aligned with each other. Like you might have DNA and then you have histology and they're not part of the same patient or something. There's also architectural, how do you embed these things in the architecture? So this is obviously on the data and model side. The one that's super interesting is the first two. How do you get access to compute? And how do you manage the increasing number of parameters of these models? And that's what InstaDeep is tackling. So the first one, we built an internal cluster called Kyber that is going live soon. It's, I think, 0.5 exaflops of compute, in-house compute of power, which is huge. And what it enables is for our teams to just routinely train these foundation models and do lots of tests. But what I think is super exciting is more the parameter side. So imagine you get access to all the compute in the world, but then the question is, how do you best use it? So when we're talking about scaling, obviously, if you can make a small change that to your system that makes it faster or more cost effective, you can get huge cost effective gains. And so it's all about the engineering behind that compute. So things we do. For example, on the software side, when you have a huge model, things like sharding. So I'm sure you all heard of this. It's basically you break down your model into different parts, and then so you can orchestrate a bunch of machines together. So part of your model is computed in one, part of your model is computed in another. You also have things like you can have memory hurdles. For example, if you have, as these models become bigger, you have to keep lots of computations in memory, and so you have ways that you just compute a part of it. Whereas you maintain another in memory. So things like that are really helpful. And one final thing that we do is more on the hardware optimized kinds of algorithms. I actually learned this recently. One of our teams was working on that, which I found super, super exciting, which is you actually adjust the algorithm to the hardware you're going to use. If you're going to use A100, V100 GPUs, or you're going to use TPUs, these have specifications like the matrix sizes, for example, that they handle. So you can actually make sure your embeddings are the right size so computations are faster, so that they don't have to break down your matrices into chunks that don't fit the specifications well, and that actually has sped up a lot of our models. So these are some of the things.
I'm getting the 5-minute warning call here, so I'm gonna. No. I know it's gone. I knew this would go fast. So let's hit one more question, but I think it's an important one. And this is something I think of as I'm probably the least technical person in this room by a mile, but I'm still using all the tools out there, trying them, Claude, ChatGPT, etc. And I know I'm still trying to figure out what are the use cases for me. How do I really optimize them? And so I imagine you're not building these things for me, but you're still building them for users, and you have to industrialize them, get people to use them, get them to engage with them. So I want to get your sense of how that, and I'll start with you, Julia, and come back down the line. How does that work in terms of making sure people are getting these things, the right people are getting them, and using them and optimizing their work with them?
I love this question. That's the answer is product. So yeah, basically something really cool here is speaking to users, right? So we build all these general models, but ultimately, like all these general models, what are the high value use cases? Like you might build a huge model with all this data, but your downstream tasks can be different ones, and where are the highest value use cases, and how do you find that out? And one thing is just going out there, speaking to people. So we have a huge open source community, so our models are in Hugging Face, and I think we have more than 700,000 downloads as of today, which is quite big. And what we do is just go out there, ask them about like what are your challenges, running these models, and it's actually quite surprising. We see things like running inference, just basic inference for a computational biologist can sometimes be super challenging. So even though we make it accessible, model, it is sometimes quite hard for them when you want to run them in production or you want to run them at scale. It is a problem. And there's other things like customization, right? So people want to see these models on Hugging Face and they're like, right, but I want to use my own data and I want to specialize it in my own use case. And so how do I do that? And there's sometimes a big gap there. And maybe one final thing is, you know, these models that we're developing, I feel like their lifespan is becoming shorter and shorter because there's these new generations of models coming up, like V1, V2. I think you guys have H-Optimus 0. I'm sure, you know, 1 to H-Optimus 1, 2, 3 is coming. You know, all these versions of models are coming up, and it's like, how do you keep up? You know, someone like a biologist, like their focus is more on computational biology. Like, how do I keep up with the new architectures and all of that? So those are the things we do with DeepChain.
Yep. JP?
How do you know that H-Optimus 1 is coming?
You told me.
Okay. So, you know, we are an early stage startup, less than a year, so I would say that we have not completely solved the product market fit. There was a panel here before us about, you know, investors, and the question was, do you invest in horizontal or vertical AI? We clearly are horizontal, and they said they invest in that, so that's cool. But being horizontal, meaning we have a model that can address massive market because the model can be used to make drugs, to help diagnostics, etc. But let's say the challenge for us is once you have a very generic model, how do you make sure that you generate revenue and manage to you know, to find your product? So far, because we are a very horizontal model, what we're doing is that we follow the product market fit that standard foundation models do. So we have, for example, we have released this summer a model for one modality, which is histology, so a type of image that you get in the hospital. It's on Hugging Face. It's going to be on platform of hyperscalers, so that, you know, we use the ecosystem, I would say, to bring our foundation model so that other partners, could be AWS, GCP, some pathology labs, etc., build platform that connects to our API and gives the users easy access to it. So this is what we do for the moment.
Great. And Robert, you get the last word.
Very short. It's in the business model, so we sell the result of our platform, we sell the drug candidates, and not the platform itself, because the community of computational chemists is very small, and the new tools that we bring are, they require a lot of training. So we hire people, we train them internally, and we sell the result of the platform.
But on that end of it, then it's more of a classic research sale rather than you have to worry that you can explain quantum and hybrid computing and
exactly,
AI and all
because pharma know exactly how to assess drug candidates. There is blueprints, so we just show that our drugs work.
Great. Okay. Well, I believe we have hit the finish line. Thank you for your patience.
Very much, Julien, Jean-Philippe, Robert, and Chris. Thank you very much for your insights and for your time. The next session will be, we will explore AI-powered medical assistants and how they are transferring caregivers' work life. For people to exit the room, please, if you want, you can take the door at the back of the room, please, just to ease the flow of people in the room. Thank you very much. See you in 4 minutes, 3:45 sharp.
c'est chaud.
On est parfait là.
Okay, welcome back to the central room. Happy to have you here again. Have a seat. Come on, you can unmute your speakers if you are watching us online, because we continue in the healthcare sector. Please welcome on stage Nacim Rahal, the Senior Director, Data and AI at Doctolib.
Thank you, thanks everyone. Very happy to be here with you. So today I'm going to talk about how we're using AI at Doctolib in order to transform the work life of caregivers. So at Doctolib we basically have two missions. The second one is probably the one that you may be most familiar about, helping people to be healthier. And that's what we do in particular by helping patients get the access to the care that they need by taking doctor's appointments, for instance, and that's what we mostly know about Doctolib in France, in Germany, in Italy, and other countries where we are present. But in fact, the first mission that we have is to improve the daily life of health professionals. That's what we're striving for, and a lot of the work we're doing is to provide them with solutions to help them run their practice. That can be from a clinical, financial standpoint, to also cooperate together on complex patients' cases. And in fact, I mentioned the clinical solution already. That's where we're investing most, especially when it comes to AI and where we're using AI to transform their lives. So the consultation assistant, which we've launched on October 15, is actually an example of that. And what it does is pretty simple. It's going to listen to the ambient sound during a consultation between the patient and his or her doctor. And then from that, be able to come up with structured notes. This is a screenshot of the clinical software that we provide to practitioners. The left-hand side and the middle is actually information about the patient, medical history. It can be information about the past consultations. On the right-hand side, what you see are notes that have been automatically generated. And some of the notes are raw text, some are half structured, some are completely structured, like weight and height at the very bottom. And the purpose of that and of that full integration is that as time goes by, we're going to be able to collect and structure more medical information, to store it back in the patient file, and then help practitioners provide even better care. So what I want to be doing with you today is to walk you through how we went about building that system, give also some of the details about the implementation, and hopefully give you a better sense of what we're trying to achieve overall with that kind of AI-based clinical solutions. So, of course, it's AI in healthcare, and it's at scale. Just to give you a sense of the scale, so Doctolib is used by 90 million patients and about 1 million practitioners, depending on the solutions that we provide. And specifically for the consultation assistant that we've launched a bit less than a month back, if you take the current numbers we have, it's about 100,000 consultations per week that are being powered by that system. And that's only the beginning, but that's a scale that requires already super robust evaluation. So that's actually the first thing that we've built. And of course, the world is messy, so I'm going to show you a more ideal view of how things went. In practice, it was a bit more complex than that, and I'll touch about that complexity at the end of the presentation. But first step was to build the evaluation pipeline, and it's more tricky than it seems for two main reasons. The first one is that it's actually difficult to define what good looks like. There are standards about what consultation notes should look like in terms of structure, but not in terms of quality of the content of that note. So just being able to define what result has to be achieved is something that has actually taken a lot of time and a lot of work with practitioners to come to something that makes sense. But the second point is that we cannot use what practitioners do today as a baseline. So today they are taking notes manually using their keyboard, and the median note that's being taken is about
140 characters. So that's actually fairly small. And we know that with that kind of system, we can be much more comprehensive. And I think you can start to fathom the improvement in terms of collection of medical history and care improvement that this type of system can bring by collecting much better consultation. So what we decided at the beginning is to look at 3 main metrics. The 2 first ones are actually integrated in a pipeline and can be run offline. Medical turnover rate, how good are we at understanding medical vocabulary when it's being spoken? And the second is factual recall, which is compared to an ideal note, how good are we at retrieving all of the important medical facts that we want to see in that note? User rating, of course, super important. It's something that we can, of course, only collect online. And then feedback, more textual feedback was super interesting as well to put some more colors on the metrics that we're getting. So first iteration, what's the simplest thing we can do to actually evaluate the evaluation pipeline, but also to give something in the hands of practitioners, because we want to get their feedback from day one in order to be able to iteratively improve the system. So we went with something very basic. For ASR, we use Whisper, which we already had some experience with and had benchmarked against other solutions at the time, and it was actually a good starting point. It's not the end of the story, but a good starting point. And synthesis, we were super hopeful, and we started with GPT 3.5 to just see the kind of result that we could get with a relatively low latency, because it was thought at the time that latency was super important for practitioners. The results were terrible. 41% medical turnover rate is bad. Factual recall of 49%, it's harder to actually get a sense of whether that's good or bad, but hopefully the ratings and the comments give us a sense that no, that's not actually what practitioners were looking for. So again, we did the simplest thing that we could do to keep users engaged, because we had a beta testing program, and even the most engaged beta tester would drop with a system like this. So we went with just switching the model we were using for the synthesis and trading basically speed for quality. It was not obvious that it would work out, but it turned out that because what doctors are looking from that system, because what they are looking for is mostly peace of mind, they want quality. They don't necessarily want more efficiency or speed. They want quality, and they want something that they can trust. So with that, we could at least keep users engaged to keep the system running in production and starting to gather feedback and keep iterating that way. At that point, that's where the real work started. So we started to fine-tune the ASR model in order to be able to have it work better in a consultation setup, which is very specific in terms of ambient noise, but also about being able to understand more of the medical terminology. And we started also prompt engineering our way towards having a synthesis that is closer to what we think practitioners are looking for. And we could see, it's interesting, because we could see that the technical metrics were improving a lot, but the user rating, not that much. And usually when that type of things happen, it means that it's time to go back to the evaluation pipeline and make sure that what we're actually optimizing for is what your users are actually looking for. And we made a few adjustments. So first one, obvious one, having more user-focused metrics. One was just to compute user rating per practitioner and not per consultation, because it's, of course, biased towards heavy users who tend to be satisfied. But we're also starting to go a little bit deeper and try to be able to evaluate the style of the synthesis in terms of conciseness and redundancy, and also go one level deeper in understanding the medical domain. So having more specific medical turnover rate metrics scoped to drugs that are something super difficult to actually capture at scale. There are so many drugs existing that we want to be able to be good at that. And also understanding more the complaints. So that's one side of things. The second thing we did is to improve the relevancy of the test that we were running. And it has twofold. It's about the data that we're using to evaluate the system, having something that is of much higher quality, multiple passes of reviews with people with medical background, and also trying to craft tests that were designed to fool the system and make sure that it was not actually falling into these traps. So with that, we just ran the same evaluation the new evaluation on the same system, and the results were interesting. Like most of the metrics went down as expected, but one went up, which was the factual recall. And that was actually a good sign. It meant that in some cases, the system was generating something that was better than the quality of the data we had and that we were using at as our ground truth. So we knew we were on the right track and that we could kind of crank it up a bit, go one order of magnitude higher, and be able to fine-tune the systems on thousands of hours, not hundreds, testing even more prompts in order to improve the quality of the synthesis. And eventually we got to something that is really transforming the life of caregivers today. Like the feedback is actually super positive, sometimes really moving in the way that it's changing the way that they are doing their practice. I was mentioning that real life is messy. So I showed like a diagram with 2 boxes and 1 arrow. That's actually closer to the reality with more things happening behind the scenes. I guess the most important thing to emphasize here is that we're not just using the transcript to generate the notes, we're also integrating information that are coming from the patient file. And that's an important point because we think that this system is a basis in order to improve the quality of the medical data that's being gathered so that we can then use it to even better support practitioners with that medical data. And at the very bottom, medical coding, I did not talk about it at all because it would require like its own presentation, but that's actually a key piece of the system to be able to structure medical data and store it in the patient file. So that's really like a flywheel that we get by collecting better data. We'll be able to generate better synthesis, etc., etc. And we're done? Not quite. In fact, behind averages, there can be huge variations. The obvious one is about the microphone quality, and you know it just takes one key opinion leader that's actually using a super bad microphone to destroy your product. So we did a lot of work to understand the lower end of the distribution and also be able to recommend hardware to practitioners to make sure that they have a good enough system, integrate some of that of these recommendations in the product itself, and also individual preferences of caregivers. In some cases, it's just about the fact that they're working in different specialties. So we have adaptations by specialty, but there are also idiosyncratic preferences of different caregivers. Not something we're addressing today, but something that we're thinking about. And the hard thing now, especially as we're in production, is to keep iterating quickly. So we're still running a beta testing program in parallel to be able to keep iterating and improving on top of what we're doing without disturbing practitioners who are using that as a productivity software and don't want to kind of see things moving up and down as we improve the system. But the hardest part is to actually be able to, remember the previous slide with all of these different components, be able to tell where you need to invest in order to eventually improve the quality of the whole system. And that requires a lot of work. You cannot backprop your way like through the whole chain. So typically that's one of the examples that I wanted to show. On the horizontal axis, it's different versions of the speech-to-text component that's getting better and better over time. And on the vertical one, it's actually the factual recall. And from that, you can tell that basically the last 2 iterations were useless. It's a bit more subtle than that, but that gives you a sense of the type of things we want to achieve. And finally, we really see that assistant as a backbone on top of which we can either build other systems to collect more data for practitioners. So dictation is an example of that. It looked like a quick win, but in fact, we're going to end up using a very different speech-to-text model than Whisper to be able to power that use case for many reasons. But it's also the backbone on top of which we can help even more practitioners when it comes to automating documentation tasks, such as letter generation, and also be able to help them in their practice. Patient at a glance would be about showing them at the beginning relevant information so that before a consultation, in just like 15 seconds, they know what's important about the patient. And you can only do that thanks to the quality of the data that's being captured with the consultation assistant. Thank you.
Thank you very much, Nacim, for your presentation. Thank you. So we will take a 5-minute break, and before our next panel on building sustainable AI infrastructure. So 4:05. Please exit the room back by the door on the back of the room. Sorry, please, just to ease the flow of people in the room. Hey, welcome back to the central room. Now, let's tackle the backbone of AI with building sustainable AI infrastructure, quantum, open and modular systems. So without further ado, please welcome our moderator for this session, Alban Bruyas, Chief Operation Officer at Scaleway. And our four panelists, Rahul Alvarez, European Market Development Manager at Open Compute Project Foundations, James Coomer, Senior VP for Products at DDN, Jean-Marie Verdun, Senior Distinguished Technologist at HPE, and Jean Senellart, Chief Product Officer at Candela. The floor is yours.
Thank you very much. Hi, everyone. Nice to see you all. We have not a lot of time and a lot of amazing people, so I will do a very, very short introduction to make sure they can say everything they have to say. So, as we said this morning, we have passed a new step. We are from LLMs to multimodals. We have passed from 1,000 GPUs to tens of thousands of GPUs. And when we talk about this, we talk about a lot of hardware which is evolving, which has to be much more flexible, interoperable, and we talk about what about sustainability? And these are the topics that we are trying to talk about today. First things first, it's AI Pulse. So let's talk first really about AI. And Jean-Marie, I would be interested from your point of view to tell us what's happening about hardware. What is happening when we say that it's so much scaling and that we are multimodal and so exponential in the growth?
I think the biggest challenge that AI is facing currently is the complexity of the systems. And what we do currently at HPE is we are getting inspiration from what we have done in the past within the HPC world. So you might not be aware about what happened during the past 20 years in HPC, but we optimize systems for 10 to 20 megawatts of power consumptions. And what we are perceiving today is the same kind of class of systems within AI. So this requires a deep understanding of how to manage these machines, how to recover from errors, and how to properly interconnect all the CPUs and the cooling technology just to be sure that everything works smoothly. The complexity of the machine is way much higher than many people believe when dealing with AI. So we face a lot of software engineers willing to train new models. So my recommendation will be just be ready for hardware failures, because hardware can fail, even if we try to design it with the highest quality. So you have to be sure that you are not losing everything just in case of a single hardware error. The other thing is, due to the fast pace of AI market, we believe that standardization is something which is critical, and that's why we are so involved into OCP.
And can you tell us more, Jean, maybe about what will bring quantum to all this and all this exponential topic?
So I think you say the word exponential. So we know that we are growing and everything is growing, but still linearly. Whatever we do classically, whatever is the technology, ARM, Intel, or GPU, or AMD, it's still linear increase. So we can double the power, we can triple, we can make intent more bigger, still it will still increase linearly. And we need now to have some kind of disruption. And quantum is one of the possibility for disruption in the hardware side. And let us not forget that AI evolution has been thanks to all the progress in hardware. So hardware is at really the central place here. And we are hitting a wall, we are not seeing it yet, but we are hitting the wall of the atomic scale. And there is one solution that can break this wall, is quantum.
Thank you. And about exponential, about atomic, about the need for AI, there is not only the need of calculation, there is the need of storage of data, because of course multimodal means much more data, from 1 to 20. Can you check?
Yes, there is. Who loves storage in this room? Any storage fans? Okay, that's about 3 people. Okay, yeah. So storage is important for performance and efficiency, because everything's waiting for us. The GPUs, the CPUs, the networks, they're waiting for the storage typically, and storage is often a bottleneck. So we need to do clever things with the data path to make sure the infrastructure is maximally utilized. And when it comes to managing failures, typically with AI, these GPUs, some of them are more stable than others. And for these large training runs, might be running across 1,000 GPUs, might take a month. And you need to checkpoint those models out of memory into some persistent storage so you can recover quickly from failures. And that's a really tough problem, and it's one that if you talk to Azure, the very large systems building these largest multimodal models, it's a critical part of that path, is protecting the system from infrastructure failures, and that really relies critically upon the storage.
And so, Rahal, you're the last, but least and last. What we wanted to know is we see different technologies which are operating all together. What is really the role of OCP? What is doing OCP for this and for AI?
So I think that the key element here is openness and readiness for scale. I mean, we are seeing that, as Jean-Marie discussed, we have this need of standardization because we have this need on growing at scale. And the value that OCP and OCP solutions provide, and the OCP community as well, is, first of all, this forum of discussion to push for new standardization, for instance, in quantum, and at the same time, this supply chain, which is actually, and those designs are actually designed for scale, that could be used for by about any vendor or any end user or implementer in the market.
And about standardization, Jean-Marie, can you tell us more about what is doing at HPE and what is your vision on this?
I think what is critical to understand with AI is that the pace of innovation is very high, also at the hardware level. So we are seeing new GPUs coming to the market every quarters. We are seeing new CPU architectures. So Ampere was here this morning, but we are also seeing NVIDIA Grace Hoppers or RISC-V or any Darius chip architecture. And the challenge is how to integrate that at a fast pace into systems. So if we were using the standard design process, we'll be struggling at delivering system just right in time for the end users to benefit from these machines. And due to that, about, I would say 3 years ago, we started to discuss between vendors just to try to design modular systems where we can replace some component of the machines as fast as possible, avoiding to redesign the whole systems, and creating a new standardization workgroup inside OCP where we can share these design rules and being sure that everything would be compatible between vendors. And that is really critical for the adoption of AI and for the growth of AI and to introduce disruptive technology. So because we cannot redesign specific systems for each generation of platforms. It's too costly, it's highly risky, and it's not valuable too. So DCMHS is the name of the work group. That's the standardization work group where you can find all the chip vendors, you can find all system vendors agreeing on new standards around modular hardware. And we believe that's the way to go just to save cost and be ready when new technology reaches the market to lower the power consumption of the systems, because we are speaking about 20 megawatts, 40 megawatts machines, which is very, very high when dealing with trainings. And that number is going to keep growing with the complexity associated to it. And the upgradability of the machine is really something critical if you want to stay in the race of AI.
And in quantum, we talk about standardization. We have a lot of companies, great French companies. We have chosen Candela since the beginning for Scaleway, but anyways, there are other companies. Maybe I'm going to make a joke that only the old people understand, but are we more between VHS and Betamax, or are we more on the standardization way between quantum companies?
No, I think it's really like VHS. So all the systems are different. So it's not just that there is different technologies. That even the way we put the technology together is not yet mature. This engine, this machine, this device are built by physicists and not yet by production facilities with a long experience of building hardware. So at the hardware itself, I think it's very hard to make any compatibility and any standardization yet for the moment. Still, at the connection point, at software, we need to be open. We need to work hard to make interface compatible. It was very hard for GPU to enter HPC, and we need to break that time for quantum. So it's really important. So it's not easy, but it's really super important that at least the software side is opening to standard.
And Rahal? Something is happening at OCP on quantum, or?
Yeah, actually, I mean, that's perfect because it gives me the segue to actually discuss that, yes, we are actually working at precisely this, the main topic about quantum interoperability, which is actually, first of all, quantum applied to connectivity, to networking, but at the same time, how we standardized interfaces between the quantum world and the standard computing world, HPC world. And this is happening at the moment. Actually, we invited Quandela to participate to OCP recently. And this is something that I'm actually quite proud and quite happy to.
Okay, so, and we have to talk about the elephant in the room, like said this morning, a lot of GPUs, a lot of consumption of electricity. This is something that is very difficult, well, interesting in different point of view, environmental point of view, but also disponibility of power, because this is the issues for cloud providers as we are today, is how we find enough power to use these GPUs and give the capacities to all our customers. What is really done in all your companies? I don't know who wants to talk first, and we can maybe Jean can finish on this topic because it's a bit different. What is really done at HPE and DDN on this topic?
So currently what we are trying to do, for example, is to remove all the fans from the systems. So the cooling subsystems into AI machines, when based on fans, is drawing a ton of power just to move fresh air into the machine and to cool down the GPUs. So we design systems without any fans, and that's the best way to retrieve all the heat from the machines and lower the power consumptions. That's the first step. The second step is to shrink down the machines to smaller count of racks, so lowering the distancing at the networking level. So the smallest it is, the less energy you have to use to transfer the data. And we are able to build rack systems which can consume up to 400 kilowatts currently, which is a lot. That's for one rack. Many data centers cannot accommodate such solution. But we keep pushing the boundaries just to try to use the power only for the computation, and that's something which is critical. We just want to reach the best PUE, and that's the biggest challenge that we face today. Last words on the open things I forgot to mention is when we deal with open standardization, it means that all of you can participate to the design of the systems. So if you identify something which is missing at the hardware level or management level or hardware recovery level, you can provide feedback through OCP, and it can be integrated within the next generation of platform. And this is also super critical that end users like you or partners or cloud service providers like Scaleway provide these feedbacks just to enhance the whole ecosystem. That's something critical, and that's why OCP is very important.
Yeah, so who in the audience thinks out of storage, compute, network in that big AI data center, who in the audience thinks that storage is the biggest consumer of energy? Network? Compute? Okay, people were listening. Yeah, you're quite right. I mean, storage tends to be maybe 10% of the total energy sort of spend on large data centers. But that doesn't mean it's not important. And going back to the standards question, we need standards to be able to plug in to the storage flash devices, to be able to tune it down and tune it up as we require storage resources, and then sometimes we don't require storage resources in terms of performance. And then we can ramp down the power, just like we've been doing for years in CPUs. Computers automatically manage the power consumption based on what's running. So we can do that in the storage as well. We can really ramp down the power when we're not busy. And then when we're busy, we want speed, we can ramp back up again. So we can take that 10% and we can squeeze it down. We can do it dynamically. But actually the biggest help we can make to the whole infrastructure is by delivering data faster. Because that 80% of compute is sitting there burning kilowatts whilst waiting for data. So actually the biggest piece we can take out of the energy pie is by delivering data super fast and stopping the I/O wait.
Other topics also on OCP, really working on this topic of sustainability or at least less consumption of power for the same performance?
Well, actually, coming back to Jean-Marie, the fact that we are actually standardizing for let's say Open Rack here, which is actually an open standard by OCP and by Meta, it allows us to have a platform which is actually inherently sustainable by itself, because it has to be ready for scale. So it's not only about, let's say, sustainability by itself, but it's about we have to deploy this massively, and it has to meet the standard, the sustainability requirements. So I want to go back to the choice of materials, the vanity-free designs. I want to go back to actually discussing about liquid cooling, which is actually fundamental for the AI era, where OCP has done a significant work in terms of standardizing direct-to-chip cooling, DLC cooling. This was actually an issue of multiple vendors where we didn't have, let's say, an agreement on how the systems plug to the manifolds and how the fluid is actually getting into the systems. And this has already been certified. I want to discuss about our OCP Global Summit, where Meta and NVIDIA presented, let's say, a complete solution based on OCP equipment, which is actually open, and where we could actually find on the floor different vendors among HPE presenting more or less the same implementation. So we had companies like ASUS, we had companies like Wywin, for instance, where they were actually showcasing this kind of solution that could be purchased and implemented by end users. So I think that this gives you an idea of the power of openness and the community that we're working within OCP.
Jean-Marie, I know we are making you talk about hardware, but you're no expert on software. When we talked before this roundtable, you were talking also about what you think of the way the hardware would be used and what we should say to the software people which are using all these GPUs to make it more sustainable. What responsibility do they have and how they could work?
I think when there is a very high speed of innovations, you really need to take care about software portability and be ready to switch from architecture to architecture. That's really critical, because we can design innovative hardware which is more sustainable, more modular. But if you are unable to make work your application on this hardware, so that's totally useless. And my biggest fear currently is you are used to use a pretty common architecture currently based on x86 instruction set and various GPUs. All of that is going to blow away within the next couple of months or even years, but the time frame is pretty small. You will have a much wider product portfolio available for your use case, and you will have to select the right systems if you want to be sustainable and cost effective. So my recommendation to software people, just be ready to port your application to any kind of hardware and try it now. Because software people tend to believe that it's easy to port software. That's not true. So I was part of the ARM engineering teams at HPE when we launched this new architecture inside our portfolio. And the whole pain was on the software side. It was not on the hardware. Hardware is easy usually, because when it doesn't work, it's pretty fast to identify that it doesn't work. The machine doesn't boot or crash. So with software, you really need to qualify, test, validate that the whole stack is ready. And usually you are way too much optimistic. So just try it as much as you can. That's really critical, and that's the best way to be more sustainable, because you will have to run and adapt your software to the hardware. So that's a couple. It's not just a software solution. You need to be sure that you run on the right hardware platform.
Jean, I have a problem. I want to ask you two questions at the same time, because at first my question was about sustainability and what will bring quantum, and at the same time, what is saying Jean-Marie about software and adaptability to a new technology is really on your side. Could we have the two?
For the first one, the answer is more a promise from quantum. So Jean-Marie was saying that they need to make sure that power goes to compute. For quantum, we need to make sure that power doesn't go to compute. Why? Because the particles that we are manipulating are particles that have billions of watts. And if we put energy in that, then we are losing the quantum effect. We are using the quantum state of the particle. So this computation will be energyless. And energyless means attojoule, something that's minuscule. So on our side, the promise is that computing with quantum, we should not use energy. But, there is a but, everything around to make the system working has a cost. We need to make system cold, we need to make vacuum for some technology, we need to make special condition with laser to stabilize the atom or whatever. This costs energy. So there is the compute should not take energy, the rest will take energy, and there is a balance here. The promise is that the compute power will be exponential and the capacity will be exponential, and the energy usage should be linear. So at some point, this will balance. So today it's not the case, obviously, but it should balance, and it is totally different perspective. And for the second point, it's super hard what you're asking, Alman, because making software compatible with hardware like quantum is not easy. Quantum is using totally different perspective, totally different algorithm, and it's very unlikely that we find a universal compiler that will take some code that will make it working for any quantum. It will be the other way around. We have some quantum, and we'll find some application that can be built on the quantum. So unfortunately, it won't work that way for quantum.
Thank you. And we can say, we're going to bit of branding, marketing, that we launched a product together, which is Quantum as a Service, exactly for this. Just try. This is the idea. New technology, let's try.
Yes, and yes, let's try. Do try. It's free. Go and use a real quantum computer. It's not everywhere where you can do that, and it's fun.
Thank you very much. The last point was about liquid cooling, but you talked about it already. Yeah. No, this is great. When it goes like this, it's much better.
We can actually elaborate.
Yeah,
we can elaborate on that.
Yeah, I think we should elaborate, because what we said is that what people have to understand is that a few years ago we were at 6 kilowatts for a rack. Now it's 20 to 40. They announced on NVIDIA side 250 or 300 kilowatts per rack. This is something where air cooling isn't feasible anymore. So we have to find new solutions. This is a big investment for everyone, because it's designing servers for liquid cooling. It means also designing data centers for liquid cooling for this specific application. So yeah, there is a lot of topics I would be happy to hear about more.
Yeah, and actually I want to go back to the issue of standardization or specification in that sense, because we actually saw at OCP, and liquid cooling is one of the largest discussions in terms of people involved and projects involved. We were seeing around 8 years ago that everybody was trying to do their own thing, and we are actually seeing new companies, for instance, coming into the immersion cooling market, which is a type of liquid cooling, where they want to do things their own way. And one of the great things about OCP is that they are able to somehow stand in the shoulders of giants. So in the sense of taking advantage of those specifications that are already been released, and go up to speed as with any other company providing this kind of services. So my point is, yes, we are seeing, and actually, I mean, just going back to what you mentioned, 8 years ago, you go to a data center operator and you say, hey, I want to bring water to my rack. They will call you crazy and kick you out. But right now, we are seeing that thanks or due to the need of more dense computing applications like AI, the air has a limit. And we will see actually very soon that even some types of liquid cooling, they will have a limit as well that we need to somehow surpass. There's a massive community discussing and ahead of the way in terms of R&D about liquid cooling and other kind of cooling technologies in OCP. I encourage you guys to, well, you can actually reach to me or go to the website and check this. But it's a given that we are actually ahead on the curve in terms of cooling requirements because we are seeing that more and more those systems, they need to be more dense in terms of compute, which we are enabling. And at the same time, that density requires, that means more power requirements, more power density requirements. So yeah, we are seeing that liquid cooling is a fact right now in the data center, from the server to the rack to the facility itself. And this is something that it's well covered within OCP. This is something that HP is actually implementing very well as well, because it's here to stay. We are going to see that air won't make too much sense for this kind of high-level applications.
Liquid cooling has a limit? What is the limit? Do you have figures? I don't even know them. I would be very interested to know.
The main discussion right now is the power density on the chips. So we are seeing that, well, we are starting to see, and we are seeing right now that we are getting 2 kilowatts per chip. And this trend is actually, I mean, the expectation is that this is actually going exponential. So the issue will be, okay, what we do when we have 5 kilowatts in a chip. So it's not only about the cooling, but about the power delivery as well. So we are seeing a future where maybe just cooling by water, as we do right now with DLC, won't make sense at all because this would be insufficient. We are actually getting way ahead of that, so we are okay right now. But we will see that we will need other kind of technologies in liquid cooling to be able to match that kind of power delivery capacity on those chips, that kind of heat that those chips are going to generate.
So Jean-Marie, you are now working, HP is working hardly on the liquid cooling and changing a bit the way they are working for this?
Yeah, we adapt our technology. So as I said, we are delivering today racks which can sustain up to 400 kilowatts. So that's the top-end configuration for our supercomputer class systems. The good news is that liquid cooling history at HP is about 30 years story. So that's not something new on our side, because we are using liquid cooling for supercomputers for many years and decades. As Rahul mentions, with the power increase at the chip levels, there might be some tricky things to be done to cool them down. I'm more optimistic than Rahul, so I think we can manage that. I would say it's probably still a little bit secret at how we are doing it. But the biggest challenge that we oversee is how does a cloud service provider like Scaleway or any others are going to manage racks which can sustain 1 megawatt per rack, for example. So that's something that we envision. This is just doubling the current top-end system configuration that we have. And the power cabling to the rack, just for example, to deliver 1 megawatt to rack is going to require massive cables, sections, and probably specific electricians, certifications, and all these kind of things. So we're entering a place where the computer is going to become a safety issue rather than anything else, and it's going to be an industrial tool instead of being, I would say, something you can have on your desk. But that's doable.
When you say 1 megawatt per rack, I just visualize the difficulty that data centers have, not even for all you said, which is important, but have the power. Most of the time they say, okay, we gain 20 megawatts, it's great. And now you're saying
Yeah,
you can only have 20 racks.
I think right now, we, as I said, we got 400 kilowatt racks, and we deliver 100 of them to HPC customers. So that's into 20 to 40 megawatt range. So the issue is really the power delivery, the electricity, and the quality of the electricity. That's the other things, because these machines can go from 0 to 20 megawatts in less than 1 second. So this is putting a ton of stress on your power and your facilities.
Yeah, we have to stop, so it has to be quick. No, but you can say a word, but just a word, because
just
he will be
but no, I wanted to bring the topic that as we reimagined the rack to be able to achieve this kind of density, the data center itself and the data center facility needs to be reimagined to be able to catch up. That was my only point. Sorry.
It's not a little point. Thank you for all of you. Thank you very much. Thank you. It's done for today.
Thank you.
Thank you very much, Alban, Rahul, James, Jean-Marie, and Jean. Thank you very much. So next topic will be in 5 minutes to discuss AI's impact on transforming financial services. To exit the room, I remind, please take the door at the back of the room if you want. You can stay, of course, for the next talk. Welcome or welcome back to Central Room. Now we are diving into the world of finance with a session on how AI roles in transforming financial services and becoming essential. So please join me in welcoming our speakers. Fabrice Le Chatelier, Head of Data Science Office at BNP Paribas. Anan Wazan, Partner and Generative AI Global Lead at Artefact. Johan Jacob, CEO and founder at FlowX.ai. And this session will be animated by Solène Bréban, investor at Balderton Capital. The floor is yours.
Hi everyone, thank you so much for joining our session today. So we're going to speak about the role of AI in transforming financial services. I'm going to be your moderator. I'm Solène Bréban. I'm an investor at Balderton Capital. We're a multi-stage fund investing from pre-seed to IPO in European founders. I'm going to let you introduce yourself first.
Yeah.
Fabrice. Yeah.
Okay, I'm Fabrice Le Chatelier. I'm working for BNP Paribas. I'm the head of the Data Science Office, and the Data Science Office is coordinating the work of roughly about 700, 800 AI professionals spread across the various entities of the group.
Hi everyone, my name is Hanan. I'm a partner at Artefact. Artefact is a data and AI consulting company, and I'm leading all our AI and Gen AI offers, and really happy to be with you today.
And hi everyone, thank you for inviting me today. I'm Johan Jacob, I'm CEO and founder of FlowX. Been working with the same team of co-founders and core engineers for almost 2 decades now. And FlowX is a modernization, a banking modernization, multi-agent platform. We're going to talk a lot more about that.
Amazing. So there is no denying that AI has a big impact in financial services, from fraud detection, risk management, customer experience, but there are also a lot of technical questions and challenges. So my first question will be, for each of you, could you share a specific example of a technical challenge that you faced while implementing AI in financial services? Fabrice, you want to go first?
Yeah, so we got some generic use cases, and they all basically ring the same bell. The first concern we have, the first thing to worry about is privacy, obviously. Privacy, because it's not specific to AI, it's to do with any data processing activity, so AI in particular. And we're using big data sets where lots of data, personal data, it could be also sensitive data, or even sensitive use cases. Okay, so which means that the traditional way of handling things, which is SaaS services, with AI, is not going to be an option for us, unfortunately. That's the first sort of challenge that we have. The second challenge that we have is with GPUs. I mean, it's just GPUs, electricity. We need to make very responsible, on those principles. We used to have this problem for training, and we would actually sequence the training, but now we have it for serving, so it's a different problem now. The third thing that we have also on AI is collaboration. We view AI as a collaborative exercise. So obviously IT is part of this. Okay, so we need the strength of IT, we need the robustness of IT. We need to deliver professional services, production-grade services. But there's also model developers, and quite often model developers are different people than the IT developers. They can be quants, in banks, or they can be data scientists. And even tomorrow, they can actually be citizen developers, people having used generative AI. And we need all those people to be working, in the same area and to collaborate.
Have you implemented specific tools or framework to overcome those challenges?
Yes, that's a good question. The thing we do, the thing we quite like, is our cloud. Because when you're talking about collaborating, then the cloud is a great place because everyone's on sort of the same environment. Also, it's scalable, so it means it has a sort of responsible use of resources. You can actually mutualize the resources. And also because it's a private cloud, it's something that we have at BNP Paribas. It's on premises, then in terms of privacy, it's ideal. And the reason why we can do this is, as I said in introduction, is that we have the critical mass to be doing this. We're talking about roughly about 800 AI professionals on the platform every day. We're talking about 20 different teams, 780 use cases that we have today. So we have the critical mass to be sort of self-sufficient on this cloud infrastructure.
Thank you. Anan, you're working with very large groups. So what are the technical challenges that they face, and how do you help them overcome those challenges?
So I think I'm going to take the advantage to have Fabrice with me today to talk about the use case we've made with BNP. So there's a very interesting use case that we call Smart Inbox. And the idea behind it is that as many banks, BNP receive a lot of emails every day. To give you a number, it's more than 20 million per year. So it's really a huge amount of emails. And these emails are routed to the right service in order to be treated. And because it's based on some rules in order to say, okay, when there's an issue about that topic, you go to that center, there might appear some issue in the routing process. So what we have done is that we have designed a new AI algorithm based on the best of hybrid approach between traditional NLP and more advanced LLMs in order to improve the way we route these emails. So how we did it, we basically train a simple classifier with this classification from NLP and LLM. And with this classifier, we are able to increase the number of emails that are routed correctly. To give you some numbers, we decrease the number of issues in the routing by 24%. And when you know that each routing error is 5 minutes time to reroute it, you can imagine the huge impact it is for 20 million emails. I made the math for you, okay? And basically, it's something around 14 years per year. So just to give you a number of the gain we do with that. And also, another thing that we have done with this project is because we have the capability to route correctly the email, we thought maybe we can also help the person that will handle this email to answer it more correctly. So we have adapted again a suggestion of answer for the advisor in order to gain time, and we get a metric of 80% accuracy on this advice. So about the challenges, because you've mentioned it, I think that the main challenge is the integration with the legacy ecosystem. We know that even for emails, even for everything, it's not that easy. And I think that another challenge is because we wanted to have adoption and have a huge user experience, we wanted the latency to be really small. And that's the reason why we didn't use an LLM or a traditional NLP model, but we use them in order to train a smaller model that is better just to do that task of classification. And I think that this implementation reduces a lot the latency of the AI, and then it's more a guarantee for adoption.
And how do you monitor this? Like, do you use any specific tools?
It's a right question. I think that the way we monitor it is just by tracking the number of emails that are routed correctly. So we have the number of emails that are rerouted. So we have noticed that we have a decrease by 24%, and also by being able to collect some feedback from the user directly and saying, okay, is the answer the AI provide you to answer more correctly? Is it better, not better? And that's why we get both quantitative and qualitative data about this project.
Thank you so much, Johan. So you're the founder of a company that is actually helping those financial institutions. So what are the challenges that they're facing, and how can you help them?
Oh, definitely many changes. But in our case, we already have very large financial institutions, some of the largest financial institutions in the world, actually, using the FlowXI platform to build and run mission-critical applications in production. So, and for us to get there, probably the biggest challenge that we had to solve was how do you build an AI that is safe enough for banks to use, and to not just to use, but to use at the heart of their technology stack. And where we are today is fundamentally at in a really outstanding place, and thanks to our engineering team, and we managed to have probably the highest accuracy AI enterprise platform on the market. We know that because we've benchmarked it, but we also are in a place where our AI has virtually zero hallucination. Now there's a couple of things that and again, you can't afford hallucinating when you're building technology and mission-critical technology for large financial institutions. It's just something, it's not acceptable. There's a couple of things that come to mind in terms of methods that we use to get there. So first of all was probably the first thing was chain of thought reasoning. So basically breaking bigger tasks into smaller tasks. So that agents or AI agents can tackle things that are smaller bites in size. The next thing has been self-reflection. So using self-reflection so that at the end of after completing every task, the agent can check whether the response after completing that task is still relevant. Probably the biggest impact has we've gotten from employing a strict RAG, retrieval augmented generation, so allowing agents to respond to requests only based on the data that has been provided by the bank and testing that. I think beside that there's been a lot of other things, like probably 80% of the time that we've spent building AI in the last couple of years has been focused on this idea, like how do you improve robustness, how do you improve reliability of.
And how do you show like the fact that you're super secure and that the platform is robust at the time of selling the products? Like how can you build this trust at the very beginning of the relationship?
Well, it's interesting you're asking that question, because the first reaction we get in conversations is this is too good to be true. Like it's literally and I remember we had we're listening to this podcast, and because we saw that they were tackling FlowX AI, and I'm like, well, like we never spoke to these people. I'm curious how they understand it, and that was like, this sounds too good to be true. Like, but I want it to be true so badly. Like, it could be true. It can be true. And I think it's, we go through a very cumbersome sales process, because again, we put this literally at the heart of how people are building technology in these large banks. We go through countless committees, architectural reviews, and then the funny thing is, after we do all that, and our sales process probably takes like 9 months, 12 months, sometimes even more. The funny thing is, after we go through all those gates and all those architectural committees, and people start using the platform, their head explodes, and they're like, holy crap, it actually works. And I'm like, yeah, I thought you already knew that. But I think the state of enterprise software today and versus the enterprise, like somehow the enterprise software industry has failed the enterprise world in a way. Like they promised for such a long time, banks were promised platforms that would make their life easier, that would improve how they're working, that would make them agile and help them innovate faster. And the truth is, all they got was just another layer of complexity and another layer of lock-in, with more proprietary languages and proprietary infrastructure and vendor constraints. And so I think people are despite going through an incredible diligence before buying FlowX and before committing to using FlowX, it's always very surprising for us to see how people are still, amazed by the power of the platform.
Amazing. Are you using any specific solutions at BNP or like?
Such as FlowX. Yes, we have a mix of in-house and we buy also external vendors.
How do you choose between in-house and actually implementing another solution?
Yeah, that's a fair question. For some regulated models, we're being asked some explainability and some inner workings within the model, so we don't have a choice. We can't go external because sometimes it's difficult to ask the vendor, what his trade secret is. Okay, so you can't. So for those things which are, I would say, really strategic, we stick to in-house. For the sort of commodities, I'm talking about OCR, for instance, which, there's probably not much sense for BNP Paribas to, develop a skill to scan ID cards. Okay, well then in that case, we probably go to a vendor. It's a mix of, sort of whether it's strategic or not, the cost, the benefits.
So maybe let's speak about legacy system, because the financial institutions have like heavy, painful legacy systems. So how do you implement AI in legacy systems? Like, what do you have like specific quick wins, tweaks that you could share with the crowd here today?
I'll take this one. Yes, the cloud was instrumental in that respect, because what we said is when we started building AI, we used the cloud, our cloud extensively. So our lab was there, our people were there. This is where we started developing some APIs. And then basically all the sort of serving around this had to be migrated to the cloud to be nearby. And therefore we'd have a complete picture. In that process, we start using a lot of generative AI today to convert the code from old legacy systems to the new ones. This is something that is greatly helping as well.
I think that the last use case you mentioned, I think is the most interesting one. We know that there's a lot of legacy systems, and because there's a lot of legacy systems, there's a lot of old code inside these legacy systems, and it's really hard to maintain for two reasons. The first one is that because it's old legacy system, it's old language, and because it's old, it's a bit complicated to understand. I don't know how many of you have already programs, and if you know assembly language and you know Python, you know which one is the easiest one to understand. And that's why it's first really complicated to handle, and second, it's really complicated to maintain because again, it's old. The profiles that are able to maintain this kind of code are really rare. So it's a double pain. That's why I think that many companies are launching some projects around rewriting this code. And I have a public example of Auchan. Okay, it's not FSI, but I think that rewriting code is not specific to FSI. But they have made a public announcement about a project they've made, and they rewrite an old application using generative AI. Basically, they have designed a chatbot that helps developers to rewrite the application, to ask questions about it. And the numbers that they provide are really impressive. They mentioned the fact that without generative AI, it will take them 1 year just to rewrite one application. And with generative AI, they succeed to reduce the time by a factor 4. So it means that they only take 3 months to rewrite it. And it shows the impact this kind of technology can do on some really important topics like migration and code rewriting.
View as well?
Well, absolutely. Like in our case, again, like every piece of software or every flow, every application, every mission critical platform that our customers are building on top of FlowX has to connect with tens, sometimes hundreds of systems. Because the truth is the data of large banks, large insurance companies is in all these old systems, and super interesting how fragmented it is, how overlapping it is, how inconsistent it is between systems. So one of the first things that we actually did was we created, well, again, over a decade of R&D with the engineering team. We've built this novel connector technology that enables our customers to create connectors very quickly to literally any type of existing system. So including, from APIs and databases and file systems all the way to mainframes or to even systems that don't expose data programmatically. And I love what you said, because one of the interesting challenges about mainframes is, the truth is everybody kind of points the finger at them, but we actually believe mainframe is an incredible technology, but it's just been bastardized horribly because a lot of people have put and have included things that should not be in the mainframes, like things that belong in a digital layer, like pricing or product configuration and all that. And connecting with these legacy systems that enables people to extract things that should not be in there and build them into digital applications on top. Now there's two probably key things that were super important for us in building this integration layer. One was having a dynamic data model. I think a lot of platforms suffer from the original sin that they evolved from some type of business point solution, like a CRM solution or a ticket management solution, and they're paying tribute to having that fixed data model at the core of their platform. In our case, we have a dynamic data model that gets built as you integrate, as you connect more systems. And the second thing is, one of the things I realized is all these systems that contain data, they have not, like most of them have not been built for the digital age. They have not been built for literally billions or tens of billions of transactions per day that are required in today's world. So probably a very important thing is that our integration layer functions as a robustness and resilience layer on top of these systems, so kind of protecting them from overload, so pulling and queuing requests and doing like an intelligent management of those requests. So for us, those two things have been key, the dynamic data model and creating like a resilience layer.
Do you have any other like solutions like this that you've used to deal with those challenges? No?
Not that I'm aware of, no.
No, I think that there's many solutions that exist, and I think that an interesting part maybe is also how you mentioned it earlier, how you maintain all these applications, and I think this is also something that I think is really important. We know that these systems are prone to hallucination. You mentioned it, there's not 100% relevant if we don't do it correctly. And we know that in FSI industry, it's really complicated because there's more privacy, more security, and we need to be really hard and really strict with hallucinations. And something I like to talk about is to give you a metaphor about how much is really important and how we deal with that in practice. Maybe can you raise your hand if some of you have a driving license? How many of you have a driving license? Okay, so many of you have a driving license. It's a good news, I know, but maybe you forget it, but I will remember for you when you get it, it took time to get it. You had to pass first a writing exam to learn a lot of things that are not really helpful sometimes, but to know them and to have a really good grade when you pass the exam. And then after this exam, you had to train to how to drive, then to pass another exam on the field with your car. And maybe some of you have taken this exam many times, and you know how much this process is complicated. But even with that, today you have your driving license. Okay, many of you have this driving license, but I'm sure that everyone that here has a driving license have also received a contravention or have lost some points on their permit, for sure. Don't fool me, I'm sure that you have you belong to this category as well. And that translates two things. First is that how good you are to learn how to drive, you will make errors. And it's exactly the same with AI. With human, we know that there's no 0% error. We know that human is making error, and we have created a legal thing in order to deal with this issue. That's why you have radars, you have policemen, you have policewomen in the street to be sure that the law is established. Okay? And we need to do exactly the same with AI. How we do it with AI? First, in the design of the AI, as you mentioned earlier, it's really interesting. You need to be sure that you feed the AI with the right data. You need to be sure that the data that is fed to the AI is a good data with no quality issue. You need to be sure that the prompt you write, in order to be sure that the prompt of the system is well written and is really clear. You need to be sure that if you connect your AI to many applications, the connection is making in a good way. The AI knows that it needs to connect to that system for that reason. And if you do a chain of thoughts or an agentic pattern, you need to explain really simply and really correctly how to do it. And this is exactly like you, when you learn how to drive, you need to be very specific and very strict and very detailed on how you build your AI. But as human, AI can make errors, and that's why you need, after putting AI in production, to have this observability and this eye on the AI in order to be sure that it behaves well in production. And how we do it, basically it's a three-layer approach. We, at the beginning, monitor everything. So it's a very IT process. We log every interaction of the AI. For example, you put a chatbot in production. You need to store every interaction of this chatbot. So Mr. Dupont has talked with the chatbot. This is what he said. This is the answer of the AI. The AI had made a RAG process to get this chunk of data, etc., etc., etc. You log everything. And you also log the time, the latency, the cost of this interaction. After this step of logging, you have evaluation steps. And in the steps, you will evaluate not only the quality of your answer, for example, the RAG process works really well, the answer correctly the question, but also, also to know that the cost is acceptable for this interaction or the latency was acceptable, and this is the second layer. And the third layer, and I think that this is the most important one, the most underrated one, and also I think that the one that I never seen everywhere, but is really important, is this supervision layer. And supervision layer is a layer that is managed by the business, and basically it can be designed with a simple dashboard, but you have a big picture of your AI system, saying, okay, this is the number of interactions you have today. This is the topics of your chatbot. This is where your chatbot have made errors. And this is the reason why this chatbot have made error. And the AI is capable of telling you, okay, the reason why your chatbot made an error is because your chunks are too small, or because your RAG is not good, or because your ranking algorithm is not good. And we have today the kind of technology to help us to do that. And I think that it's really important to have this observability layer, because without that, we can put AI in production. It's exactly the same. Without radars and policemen, etc., I'm sure that no one will drive at 50 kilometers per hour in the periphery. That's the same concept, and I think it's really important to keep that in mind, because this is a guarantee to put AI in production.
No, definitely. I mean, I imagine that reliability, accuracy, compliance are big challenges for you as well. Do you also have any solutions or systems in place?
There's a practice which we quite like, is human in the loop, as you said. I think we found that from experience that combining human expertise with AI works very well in terms of performance, but also in terms of acceptability. This is the kind of thing that works well.
Johan, I think we have only 2 minutes left, so if you have anything else to say?
Yeah. No. Again, because we're using our AI at build time, and the IT teams in banks are using our AI at build time. We've actually gone beyond this idea of human in loop, where we're calling it human in control. So literally every output of the AI agents can be checked, and it was a very interesting challenge, how to design the journey and the user experience around creating that, making something that people feel safe about. Because sure, you can create very safe technology, but how do you also make the people feel safe? And since we're in the automotive kind of analogies, you know how Tesla has a big screen up front where you see what the computer vision understands of the real world. If you think about it, there's no functional reason for which that exists. It's not helping people functionally. However, what does that create? It creates confidence. It creates confidence that, yes, the computer, the machine, understands the world and sees the world exactly like I do it. So you tend to give it more and more freedom, and you tend to, and pretty much the similar, like we've gone through countless kind of design and iterations around user experience in AI, and embedding that human in control has been super important for us.
Thank you so much. I think it's the end of our panel, so thank you everyone.
Thank you very much. Thank you, Fabrice, Anan, Johan, and Solène, for your time and for this session. We will take a quick 5-minute break before the final talk on real-time generative AI for video and photo. You can stay in the room if you are interested in, and if you want to exit, the door at the back of the room. Thank you. Welcome back. This is our final session for the day, and we will dive into one of the most, well, it's for me, one of the most exciting frontiers of AI, real-time generative AI for video and photos, some technical challenges uncovered. Let's give a warm welcome to our final speakers of the afternoon, Elliot Andres, CTO at Photoroom, Francesco Santoni, CEO and co-founder at Mojo, Olivier Reynaud, co-founder and CEO at AV, and this session will be animated by Dunia Zouin, co-founder of Meuf App.
I have to jump on the chair. Hi everyone, my name is Dunia Zouin. I am the co-founder of Meuf, the first social network dedicated to women, 100% safe place because it leverages AI but also human. Before that, I was chief AI and data in major media and entertainment companies in France and in Europe. And I am very delighted to be here today. I will let the panel speak for itself and present. Francesco.
Hi everyone, super excited to be here. So I'm Francesco. I'm originally a software engineer, passionate about mobile, video, and AI. Turned into an entrepreneur and now co-founder and CEO at Mojo, which is an app that enables everyone to create like stunning videos for social medias like Instagram, TikTok. And basically that turns everyone into like a super video maker. And we are leveraging a lot AI more and more to generate our content and enable non-technical people to create easily content.
Thank you. Olivier from AV.
Hello, so yes, I'm Olivier Reynaud, co-founder and CEO of AV. So I'm an entrepreneur since 20 years. Before I co-founded Tids.com, the global leader in video advertising. And so with AV, we created since the last 4 years, multimodal generative technology for enterprise in order to automate video post-production at scale. So I'm not engineers, I'm more on the marketing side, but entrepreneurs in technology since 20 years and more. It will be great to talk about what it do at AV exactly.
Welcome Olivier and Andres from Photoroom.
Hello everyone, so I'm Elliot Andres from Photoroom. I'm a co-founder and CTO. Photoroom is a platform for image editing, specialized in product photos. So with more than 200 million downloads, we help companies like Amazon, Decathlon in France, Stellantis as well, create visuals that sell more. So we help automatize image editing and create stunning visuals that boost your sales.
Thank you. So first of all, maybe the why of this panel. The startups that we are hosting today have all highly demanding businesses because it's either mobile apps with B2C consumers, millions of people using those apps together, or because it's a B2B business. What AV is doing is helping companies like media and entertainment companies to streamline their video production processes. So of course this content costs a lot, and they want to have it used very well. So it's a highly demanding industry. When you inject AI into that, the first question is that your products are already live. You have millions of customers, so you have problems related to performance, to the quality of the delivery of the Gen AI that you are using. So this panel today is to dive into those challenges and how in real life, actually, besides from the keynote, the talks and the scientific papers, how is Gen AI today performant and meeting those high expectation demands. So this is the why of the panel. Maybe first of all, even though we are going to talk a lot about AI, I think it's very healthy to focus on the customers and the users. So yours are particularly demanding, so they are accustomed to very fast responses time. So how do you do it today, and how do you maybe tackle this dual problem between performance of the quality of the Gen AI delivery and the rendering of those videos, and also very fast response times? Maybe Francesco first, please.
Yeah, so great question. Basically, every product in the history has to make choices, right? So you have to make compromise and to decide where you put the bar between what you want to offer and what people want to experience. So basically, for example, there's high difference between text, photos, and videos, and also a big difference between mobile and web. And the other difference is, like, let's say, B2C, prosumer, versus B2B. So if you look at everything, if you take our example, let's say like video, mobile, and prosumer. So basically you get with mobile you get expectation about something fast because people won't wait a long time on mobile.
I think that the standard is below 1 second
yeah,
when you
exactly.
are in mobile.
Which is for video today impossible. So we try to leverage also other technologies such as like the new iOS offer you to put, like, for example, a widget on the home screen that enable people to wait while not keeping the app open, for example, small things like that. But then on the model itself, you have to make that choice. Unfortunately, video is slow and also still a bit cringy sometimes. So that's the area where you can't really do a lot. But then in photo, it's something that I think already like more mature in doing those choices between quality and speed and maybe.
Thank you for the transition. So photo room on the image side.
So on the topic, we have an interesting story. When we got started in Gen AI, we launched our first feature. So we worked on it for 2 months. We put it out to the users. We release it. You take a picture with your phone of any object, and then you have to wait for 1 minute before getting the result. And no one was using it, really. Like, it was
infinity. 1 minute in mobile
on
is
a phone.
Infinity.
Like, in that time, you receive 3 notifications. You're like, which I'm going to open TikTok. So it is an infinity. And we were telling people, okay, we'll send you an email after, hoping that it would come back, and it never came back. So we learned that having an instant result was key to the experience. We went back to the drawing board, we optimized the models, we changed a little bit the way the processing was done, and it went down to a few seconds. So it's a bit more than a second, but you still have a nice loader to wait, and you get your result instantly. And when you think of iteration time, so if you're not happy with the result that you get, it's a world between 1 minute and a few seconds. It allows you to do a few iterations, whereas with 1 minute you do 1 or 2 at the maximum. So really this speed of the model is key for us.
And Olivier, on the B2B side, how do you balance between performance and quality of the Gen AI delivery, or AI even, and then response times? Because even B2B people don't have time.
Exactly. And as an introduction, our focus is AI and video post-production. It's not produce first content. It's when you have the master and advertising from a studio or a movie, and you want to create all the versioning, the reformat, the adaptation, the summarization with audio adaptation also. This is a post-production. So when we started AV in 2019, so a few years ago, the state of the art were a little lower than today in image, video, and audio, because we embrace all of this. When we started with my co-founder on the tech and AI part and our team, so 20 engineers 4 years ago, our approach was, to give you the insight, to transform audio-visual content into data. So our approach was to say, okay, we will create an AI for each creative aspect. One AI to detect people, one AI to detect emotion, one AI to detect shots. So more than 20 AI models later, all things together, we are able to transform a video content into data. First, in the first years, we work with short video content, advertising, for example. So at the beginning, to transform a video into data, 1 minute video was around 7-10 minutes of analysis. It was pretty cool because make work together 20 AI models and together it's a huge performance. But it was long, and now we are more working with a video not of 1 minute, with movies. So imagine analyze a video of 2 hours, it will take 1 day. So the challenge we cracked on the last few years was to virtualize our AI, because we are on a multimodal generative technology approach. It's video and audio. So all our technology, we quantify all our model in order to fine-tune them to keep only the most important, because we are mainly on open source model plus proprietary model. So that's why it's fast. Now we are on real time. 1 minute video is analyzed in 1 minute. Huge performance. First, it's the analysis part. And after, when you do summarization of video, reformat, repurposing, few years ago, you click, you have your result in 5 minutes. It was amazing because without AV, you use Adobe. It takes 2 hours or 1 day to do the adaptation. But 5 minutes was long. And now, with the quantization plus the virtualization of AI, when you do your summarization, it's instant. It don't take seconds. It's instant. After, if you like it, you have the audio adapted, everything. You generate the export. It takes few seconds. So with it, we have a delightful user experience. So virtualization of our technology with more than 20 AI models and quantization of all of this. It's a huge challenge. And of course, years after years, the model evolves. There are some updates. We have always to keep update on the new models, and all our MGT technology improves nowadays in order to be at the top of the state of the art.
So now we've talked about how to have a robust Gen AI product like Live, because it's performant in its delivery, because it's super fast, because it can run on a device like a smartphone and still be very competitive in terms of responses time. But I guess that robustness of a product is also its value proposition. And when we talk about Gen AI, we have to talk about hallucinations, or at the least some exotic and unexpected results. So to have a robust product, it means that you have Gen AI delivering some kind of truth or some kind of quality when it comes to video. So today, how do you tackle the risk of these hallucinations? And if you do so, please tell us, because there's a lot of people trying to look into the project.
No, yeah, it's a great question again, because when we released, I remember our first animated model, we used like open source models and open source LoRa's too, so fine-tuned models. And believe it or not, we would like exclude a lot of not safe for work content by either like keywords, by trying to fine tune and stuff. But the models, some of the models and some of the LoRa's were so much trained on like non-safe for work data that we couldn't get rid of that at first with that model. So what we've done is like 2 things. One, counterintuitively, is also about your product and the performance. Because as Elliot said, like if you wait 1 minute to get a result, and that result is like hallucination, you will be pissed, right? But if you wait 1 second, at least you have more shot. So that's the first thing. And the second thing is what we do, instead of analyzing like too much the model itself and trying to kind of get observability with like fine-tune benchmark for each iteration in the model, we use like more high-level metrics, and basically we cheat a little bit by using some proxies, which is, for example, let's say you create something, and we will measure the ratio between like creation to download, and then for some point, like some countries or some areas, we can see like some drop. And then we see, oh, it might have like a problem. And the last part for us is also on top of all the technical observation is the customer support. Luckily enough, we don't have to kind of generate content that directly goes on the live. So we are a creativity tool, so people can validate before submitting on their Instagram account. So yeah, basically they won't create, they won't share if there are issues, and they will share with customer support.
That's why I said that those guys are working on a very high standard, because the result of what they are doing is instantly visible to the users and to the customer. Like you definitely can see the video, how it was generated. And then if they are not happy with that, they tell you guys. So can you just like give us an example maybe of some customer feedbacks that you had because you had a shitty Gen AI hallucinating?
Yeah, I think that the thing is, I don't want to steal the story from Elliot. I think he has a better one that he told me the other day. So no,
yeah, maybe. Yeah, okay. So
this one was super fun.
You're doing the transitions today. So yes, you guys decided that no model out there, no Gen AI model was enough for you. So you decided to create your own foundation model. So you're training your LLM on images. So yes, tell us. But if you want to start with the great example, you can also start with the great example.
No, before I tell you a bit more about the model we're training, we're actually facing the opposite of hallucinations with our model. So what we do is that you take any object and we generate the background for you. And the issue we're running into is that the model is too realistic. So if you shot your product with a very bad lighting, the background that will be generated will try to match the foreground, and therefore it will match the very bad lighting. So the model is following too much the input information that it has, and it's not generating good enough results for the user. So we have to trick the model into telling it, okay, even if the foreground is badly lit, is blurry, generate a background that looks like it was
so now your users are expecting to enhance the quality of their photo by using your model, not only the creative part of it.
Yes, exactly. Okay. So even if you shot a bad picture, you will get a nice background. And in the past, the model was not used to doing that. It was matching whatever was in the foreground. And so, yes, we're training our model. It cost quite a large amount of resources. Like right now, we have a cluster with 256 H100 GPUs. So training the next iteration of the model. To give you an idea, this is around 10 million euros per year to rent such a cluster. So it's a big amount of resources. So you might be wondering why we're doing this. One of the reasons is actually nudity. Like all of the open source models, they have been trained on the whole internet data, and they've learned like how to generate nudity, and we don't want that for our users. So we're filtering the data to remove violence, to remove nudity, in order to have a safe experience for the users. The second aspect is speed. With a custom model, we can control the architecture. And the last one, and it's probably the main one, we're convinced that in order to ship the best AI image model, you have to know how to train one. So that's the main reason. We want to be the best in the world, and that this won't happen by using other people's models.
And this model is going to be available through an API, right? Or are you just going to use it at PhotoHome?
Exactly. So it's available today at an API, the current iteration. We're currently training the next iteration, which is 10 times bigger. It's currently in the oven cooking, and it's going to be released in a few weeks. And we will be releasing an open source version as well, probably next year or the year after that.
You have to tell us your example. We've been teasing it for 5 minutes now, so just tell us about the dogs. That's the example, right?
So you have dog groomers using the app. So it's hairdressers for dogs. And they're using the app to send funny pictures of the dogs to the owner. So they groom the dog, and then they put the dog on the beach or on a surfboard in order to get more business with the owner. The funny picture is part of the deal. And we ran into an issue because we've updated the model, and previously the owners, they were snapping a picture of the dog on the grooming table, and the model was keeping just the dog, so they could put it on the beach. And we updated the model, and it was keeping the dog and the table. And suddenly we got on our Facebook community a crowd of dog groomers really angry because they couldn't send the owners nice pictures of the dog. So we have to roll back the model and update it in order to just select the dog and not the table.
Wild Gen AI. So when we were preparing this panel, you said that generating pixels is like fighting a battle against hallucination. Just before we move to the B2B part, how are you faring in this battle? Like, are you winning, or are we going to have to come back next year to know? We still need 1 year of work.
No, if you look at what's happening right now, basically we are like there is like a battle versus like generating pixel versus like rendering them. And a few years ago, it's like started like to have kind of debate. I think that today the debate is already over. It's not even a controversial thing to say or like a visionary thing to say that pixel generation is likely to kind of take over. If you look at even like rendering techniques, they're using more and more AI. There were like a talk just before from NVIDIA that saying that chips are not enough like for ray tracing, and they're using AI. Even like approximation, I think AI is very good. If you need like precise stuff, maybe not, and maybe not soon, but think about like lightning, shadow, and stuff like that. What will perceive a human being is not like how the shadow is actually like the actual shadow, or does it feel like a good shadow, you know, or good lighting? And that's really important. That in those areas, like it's not the accuracy that wins; it's like the feeling. And for that, I think like generative pixel will. Win.
We have to
by
come
far.
back next year.
Yeah.
Yeah. Okay, Olivier, on your side, you do not generate content, but still you have to tackle this approximation and the hallucination problem. I don't know how you're doing it when Dior just gives you like their advertising video and they want you to post-prod it. I can't imagine a world where this could be approximative. So how are you de-risking this kind of situations when it comes to video in Gen AI?
Yes, we have to keep in mind that at AV, our market is B2B and tier 1 companies. So it's like companies like LVMH, L'Oréal, Stellantis, Omnicom, IPG, or Meta also. So very demanding companies. So they have to be very accurate, everything and no hallucination. First. Secondly, about generative AI, it's great, about all the opportunities, but right now I prefer to speak about just AI, because on our side, we have the both. We work on an AI convergence, so at AV we have a lot of AI analytics model that transforms the content into data, and thanks to this old data, we use some Gen AI like audio summarization, video summarization, reformat, sentence, topic generation, etc., etc. So all of this, yes, we have a generation for the format, for the summarization, etc., and also for the dialogue in order to understand what people are speaking, who, etc. We work a lot of some diarization of the dialogue to understand more, something very determinist. So it is key topic we tackle, and all the solution on our side. All server side, so you have to be very accurate and totally determinist, no solution. So on our side, we are not in the game of the crazy hallucinative issue. And for enterprise right now, this is opportunity, but they can't use it really for advertising or movie. It's too early. There is a lot of opportunity, but really it will be at scale a global opportunity in 1 or 2 years. So we are going in this direction. AI takes years, so but we are going to it. So this is the direction we are taking. So because we buy separate AI analytics, Gen AI all together, and with a control with a multimodal way.
So this is the interesting part, maybe to be based in this real life AI project that we wanted to discuss. So there are a lot of technical teams here, and in the world before Gen AI, like in IT, software development, and just AI project, we had a testing methodology. We could, even though there were always people that said that testing is doubting, but we're not going to talk about that. But yeah, we had a testing methodology to like be sure 95%, 99% that what we are shipping live is going to be a good product and behaves the way that we designed. With Gen AI, I feel that like we are some kind of blind, and it's just shredded this testing methodology that we had. So today, like very practically, your teams, when you're delivering Gen AI project with your teams, how do you de-risk this specific testing is difficult with Gen AI, and yeah, that's it. I'm gonna stop here.
Yeah, I think like again, there's no one size fits all, I would say. Especially like, for example, if you look at LLMs and text, so we have also like a speech subtitles and smart features around that. For those, like the ecosystem is getting more and more mature, where you can have like test data set to kind of test and auto evaluation. Of course, it's not perfect because it's not 100% determinist, even with fixed seed and stuff like that. There are methodologies. It starts to still, I think, be mature. But for pixels, it's a bit more complex, to be honest. So there's like test suite that.
So what you're saying, sorry, is that we are working on it and it's becoming possible when it comes to text.
It's already, so basically, to give you a simple example, LangChain as a back office longsmith. I'm quoting this one. If other competitors are here, I know. But then you can have, like in production, all the traces of your LLM. And when you have a versioning on both, like either like the model or the prompt, when you change one parameter, you can have a new version and evaluate to get a data set. And when you have issues, you add kind of like a test, basically, the kind of failing issue to the data test, and you get like this scoring. But again, the issue with non-algorithmic thing, I think it's related to in the end, for us, in the same methodology that I was talking about before. In the end, you will see that through the kind of users. Of course, we don't have the same kind of demanding way for extreme like B2B and enterprise. So what we do is basically we use product data and we use customer service. Like and that's for most of the time we identify issues pretty thing, and we have like a score generation to download or to share. Depending on the product.
No beforehand testing, but then like iteration with the feedback that you get afterwards. Okay.
Yeah.
You guys with your LLM, are you better in your hallucination, or how do you test it? How do you de-risk your project?
It's definitely a challenge. There's a lot of once a model comes out of the oven, there's definitely a vibe check that you do with the model, where we put up a demo that anyone at the company can use, and they play with it, and they say, okay, I tried this prompt, it generated that image. One of the tests is that the previous model struggled to generate the Eiffel Tower properly, the new one does it better, so you end up knowing your model a little bit. So that's after a model is trained. Then when we go to production, we do what Francesco highlighted, which is we A/B test the models to the export. So we say, okay, if you have version 1 of the model, what's your likeliness of exporting? If you have the V2 of the model, what's your likeliness of exporting? And if hopefully V2 likeliness is higher. That's what we did for the latest model. However, it was just an average. So on average, the V2 model was better. But for the dog groomers,
that's why you missed the dog.
Exactly. We could only measure the average. So now what we're doing is that we're splitting by categories of the image. So if you have a dog image and you're using V1, what's your likeliness of exporting? And you can do it for all the main categories of your business, and it gives you more granularity on measuring if a model is better or not.
You're really doing it for each category, or are you sampling?
So it's a work in progress. Right now we have 10 or 20 categories, and we're adding this because we missed it on the last model. We don't want angry dog groomers again, and so it really is a work in progress. There's no magic one in evaluating image models. You still have to trust your users. In a way, they're voting with their export. It's implicit. They're picking a model, but they're voting and saying, okay, this one is better.
Okay. Olivier, on the B2B side.
Yeah, on our side, the thing is. We have to be totally autonomous in terms of AI in order to don't have external perturbation on us. So we don't use any API of GAFAM or OpenAI for our model. It's contractually mandatory, so for all our clients. So it's all open source inside and proprietary algorithms and models. So we can fine-tune all of them, and we can adapt and maintain them, all of them. First, to avoid all these test error and with production with client. Secondly, all our models, we make them evolve with new updates of the model. So sometimes we have the same models that evolve, so all our technology progress in the years with the state of the art. Sometimes some new models are not good for all our organization of technology. For example, the last version 10 model of YOLO, we don't use it. We use the version 8 because for our needs, it's good and it works. But the 9 and the 10, there's too much errors for our enterprise needs. So that's it. We use the last one, but not the best one, not the last one. And sometimes with some new models, sometimes we turn off 2 models, we replace by only 1, or so we all have always to fine tune. So in this way, it's something really we stabilized our technology. Of course, we are doing tests daily with all the team to improve, etc. But like every companies.
Thank you very much. It's clear that Gen AI in video, but maybe for all industries, presents a lot of challenges, and I think that we need this kind of humility right here, just to say that not everything is at the place that we want it, and there's a lot of risks, a lot of testing still to be done. So thanks a lot. It was very insightful. I hope that you enjoyed it, and see you later, maybe.
Thank you very much, Elliot, Olivier, Francesco, Dunia. Thank you. With that, we conclude our series of talk here in the central room. We have a cocktail just after, so you can continue to ask questions and to discuss with people, right? Okay. I want to thank everyone who joined us here in person or online on YouTube and on the platform. Thank you to all the speakers. Have a wonderful evening and see you next year.
you.